Right, everyone, how's it going? That is not how I start my streams. Anyways, today I'm gonna be continuing on the HTTP server, but before we do that, we got a little task from Jamie, the question mark man, for a little warm up. Before we start the HTTP server, so yeah, we can just get going. So create a class called item. Right. And then it will have, I've already got an error. Okay. It should have these fields. A string called name and an int called cost. And I believe they're going to be in private.
Yeah, absolutely.
I don't know if I need IO stream, but I'll just do it just in case. So then int cost. Right. Okay, and then it shall have implicit conversions disabled. Okay. So I think it's like that. And then when you say this line, you're talking about the constructor, right?
Yeah,
okay. Yeah, thought so. There should be two member functions. All right. Get name, which returns a reference to the name that cannot be changed. So like string, right? And then that's the return type.
That would return a copy. That would still be a copy.
The function does not change. Wait. And the function does not change the object. Okay. So in the definition, I'll do that. So same as above, except it returns a copy of the cost and not a reference. Okay.
Right.
So const. Yeah.
So what I meant was by the function does not change the object is you add a little const to the end of the function declaration.
There.
After the name of the function.
Oh, after.
Yeah, yeah. So that's saying that the function, no, after the parenthesis. Yeah. So that means that you can't go inside that function and say, oh, name equals such and such, or cost equals such and such. It will not have that.
I thought we'd do that in the definition. Also, one second, I don't think they can hear you. Okay. No, they can't hear you. I need to fix that real quick. What happened here? Bro, I don't know what's going on here. Anyways. Yo, what is going on here? So they can't hear you from this desktop audio default. That one.
That should sort it out if you're using your headphones.
Yeah, that's it. Okay.
Go inside that function.
So they can't hear. Okay.
Hello?
Okay.
Hello?
Yeah, that's fine. They can hear you now.
Perfect, yeah. All right. So what I meant was about line 32. So it returns a reference to the name that cannot be changed. So that'll be a const reference. That's what you're doing correctly there. And the function does not change the object.
Yeah.
And that's the const specifier at the end. Now, if you look on line 14, it says these functions should be able to run a compile time. So to make it run a compile time,
Const expr.
yeah, it'll be const expr because we're telling it to run a compile time.
Or did you say line 40?
And no, line 40. We're telling it. I don't like hearing my own voice on stream. It's so weird.
Wait, can you still hear it?
No, it's gone now.
Alright.
I mean, faintly, but it's alright. So, on line 32, you would specify that the get name and get cost functions are const exp.
I didn't read that next part of the task.
That's alright.
Okay.
But you also want, so it's a const exp function that returns a const reference to the string. So it'd be const exp const std string. No, not there. You're okay before. Just before the string. So you're saying that it returns a const reference.
Yeah.
And we don't need a get cost to be const. Well, the first bit, because it's only a copy.
Okay. And this should be an header file.
That is a header file. Oh yeah,
this
that's
is
yeah.
C++.
Oh yeah, that should be a header file then, yeah.
Okay. And what were you saying?
So the reason why we're returning a const reference to the string is that if we returned just normal std string without any reference or const, it would be a copy. And so we don't want to copy data if we don't need to. And so if we return just a reference, we're not copying, we're just giving it a reference. The user could change the name of the string, or change the data of the string actually. But if it's a const reference, then the user cannot make any modification to the name. It's just purely give me a reference to it, and you can't change it.
Okay. But for the cost, it's not a reference, it's a copy, so they can change it.
Yeah.
Do we want them to change it?
It's up to what the user wants to do. In that case, but because we're sending a copy of the cost, it's up to them. It's theirs now.
Is this going to be for the end user or like a developer?
The developer.
Oh, okay, that makes sense.
Yeah.
Yeah, that makes sense. Right. So if during construction the cost is below 0, it should throw an error saying bad cost variable.
Or bad cost, it's okay.
Just copy that bit as well.
So the constructor will also need to take in a string for the name and an int for the cost.
There? Yeah. No, int.
Yeah.
Okay.
You can name the variables if you want. Or the parameters.
Alright.
So right there in item, we're giving the item constructor a copy of the name. We don't need to, we can pass it in as a reference.
Like that.
But we're not changing the name in the constructor, so that can be a const for the name. Yep. And because we're not changing costs in the constructor, we can also make that a const. Yep. That's perfect, yeah.
Sick. And then so this is the constructor. We check
Okay.
if.
Do you remember? Hang on. Do you remember how to set the variables of the class? Like you.
Yeah, I remember what you're talking
the
about,
colon.
but why would we do that? Because we have them passed in as parameters. We can just use this one.
But we're setting our own name and our own cost from that. Yeah. We need a comma, yeah.
All right. Fair enough.
Yeah.
So, right. If the cost is below 0,
Yep.
then should throw
Yep.
std run error. Oh, what was it?
Your runtime error.
Runtime.
Runtime underscore error. Yeah. So you haven't included the header file, so it doesn't know what it's called.
What header file would it be?
std except. Except is an exception.
Wait, what am I including?
std except is in an exception.
Oh, except.
Yeah.
I don't remember doing that last time. Did we do it?
Some header files automatically include it.
Oh, IO string includes it, doesn't it?
I think so, yeah. There we are, yeah. See, it's lit up.
Okay, cool. So, throwing saying bad cost variable.
Sure.
Cool. The constructor will also throw an error if the length of the name is 0. Okay.
Yeah.
If name.
There's also a method in the string called empty. So you could just write if name empty.
Oh, cool. Empty.
Yeah.
Oh, nice. Okay. And in the main function, the program continuously asks the user.
Yeah. Have you implemented the get name and get cost functions?
No. Oh yeah, I should do that.
So that's in learning.cpp, but you're including from item.h, so you need to do that in item.h.
Yeah, they're made here. I've got to do
Yeah,
it item.cpp.
You can define a context per function in the header file. So you could just carry on the function, just context per const get name, and then implement it in the header file rather than in the C++ file.
Well, do the actual logic in the header file.
So you can implement get name and get cost in the header file.
Yeah, we did here.
That's just saying that's just declaring it. You need to define it.
Oh, okay.
Yeah.
So we'll just grab this again. Get name. It returns. Okay, that's why I was wondering why we had that const there, because I thought we would do that in the CPP file, not the header. Okay, that makes sense now. So return name. Oh yeah, like that.
Yeah.
That's it.
And in that function, try and do cost equals 0. Like, before the return and see what happens. Semicolon. And, what's the error saying?
Expression
yeah.
must be modifiable.
Yep.
L value.
Yeah. So an L value is anything on the left-hand side of the expression. So your cost is an L value because it's to the left of the equals. Can you see? and the
Yeah.
0 is an R value because it's on the right hand side of it.
And cost is not modifiable.
No, it's not modifiable because we've said in the function declaration that the function is const. It doesn't change the class. If you were to remove the last const, that one there, you could actually do it. So you're saying there that the function can mutate the object, but if you make it const, you can't. Now the const that you're pointing there, that is about the thing that it's returning.
Yeah.
So you're returning a constant reference to name.
So if we remove the const at the beginning, we'd need to put that. Or
No.
no. All right.
So can you see? Do you understand why I was giving you an error about the name before? So if you remove the first const again from const std string, and it's giving you an error there saying on name, qualify is dropped in binding reference of type std string reference to initialize type of const std string. So what's happened there is the function is returning a modifiable reference to name, but the function is declared as something that cannot modify the function, cannot modify the class. That would work.
Okay. Yeah, that makes sense now.
Yeah, so the compiler is just saying, right, you wanted it to be const. Everything you return will also have to be constant in that it can't be changed.
Yeah. Can't modify anything.
Otherwise, like you're bypassing that it's const, if you know what I mean.
Yeah. And then in get cost,
Yep.
expect it to return a copy of the
Yeah.
cost and not a reference.
Yeah.
Right.
The essential reason why we're returning a reference to the string name is because a string is a container. It stores something. It's got a pointer to something in memory. It owns something. And so if we were to return just an std string and not a const reference, it would copy the string, and that can be quite expensive.
Yeah. That makes sense. Right. That looks right.
Yeah, that's right. Yeah.
Give me a minute. I need to go get some water.
No problem.
Also, hello original and hello coding with Adam Gaji. Jamie, do you mind keeping the chat entertained while I'm gone?
Yeah. Don't mind us original. We're just talking about the heap, saying like it's a bad idea to return a copy of the string if you don't explicitly need it to be a copy. Are you a C purist original? How come? Do you know that a class is a struct original?
Classes and structs. Same crap.
They are. No, they're literally the exact same internally. So see, they've got different ways of using them and rating them, I think.
But can you have inheritance in a struct?
You can do, yeah.
You
They're the
can.
same thing. Yeah.
Then what's the point of C++? If C also has inheritance?
You can't have inheritance in C, and C is a procedural language. There's no generic programming in C, so you'd have to make your own vector type for each single. Like if you want to have a list of integers, you'd have to define all that again. And you want a string, you have to define all that again, and it's so much easier in C++. It's more expressive.
But they both have structs. So C++ has the struct but with added functionality.
Yeah, C++ is a better C.
So then what's the point of a class?
The point of a class is that there's some data that's hidden to the developer. You can't just go and say item dot name. You have to go through the methods,
Okay.
and that leads to a more engineered approach to your program. You have to explicitly define how how you access these things and what happens if you call this function.
Okay. So you just use classes for more object-oriented approach.
Yeah, it's for encapsulation. It makes it so much easier to develop for. Because then you've got a fixed logic for your class. It's not one guy does it this way over here in this file, one guy does it over there in that way in that file. There's a centralized way of doing it.
Cool. Original disagrees, but we'll move on.
It's really not a better language. C is not a better language at all. I just can't see how it is. Except if you're just developing for an embedded platform, but even then, C++ is very good. There's no operator overloading in C. There's no generics. No exceptions. No standard library that's not nonsense to read. There's a C library function that's about 32 characters long. I'll try and find it. You don't need to specify void in the main function there. That's a C thing, because in C it's very unsafe and you can type in as many parameters as you want. So programmers had a void, put void there, so they compiled this extending nothing. You don't need the void in the argument list of main.
Yeah. I just did it because it looks cool.
If you want to, yeah.
In the main function and the program continually asks the user for the item name and cost.
Yeah.
What am I doing? Gets.
What's wrong?
I swear it was getline. Oh, apparently
Yeah.
nothing. It was just screaming for no reason.
Make sure you add as a last parameter the new line character, so you're reading it to the new line. There we are. Oh, it has to be a character, not a string.
Oh yeah. It's a bit weird because these are 2 characters.
Not internally. They're one character.
Yeah.
If you hover your mouse over it, it should be like 6. It's actually number 10.
Oh, so you
if
can
you were
just write
typing just
10.
the number, yeah, with all the apostrophes, yeah, that will still work because internally characters are just numbers. Well, not a string 10, just like literal int 10.
Oh, just the int
lit-
10.
Just 10, yeah. And that's getting a bit annoying because, well, I'm not. It's inverting it to an integer internally, so you have to like, do a C style cast saying like, oh, char 10, and that'll be the exact same as a new line character.
Oh, cool. That's actually really nice.
Yeah,
So,
everything internally is just numbers on a computer.
okay.
So
And
here's a
then,
little quiz.
yeah.
This is about the C standard library. Okay. Just by looking at it, what does this function do? And it's called MBSRTOWCS. What does this function do? Just by looking at it. You can't read documentation. Just tell me what it does just by looking at it.
Mouse button string. Oh, wait.
MBSRTOWCS.
Member string object. Wide C#. No.
Is it? Here's a good what's I don't know how to put it. So it's a game you can play. Is it a C standard library function or is it a Polish surname? How would you know the difference?
Hey, Dixalius. But yeah. Well, so what does it actually mean then?
According to the Microsoft documents, it means converts a multi-byte character string in the current locale to a corresponding wide character string with the capability of restarting in the middle of a multi-byte character. Obviously, there's a more secure version with the underscore s at the end, like character. Obviously, there's a more.
Yeah. Bro, I don't know why you're trying to confuse me.
Right. So the next step is
Just a bunch of
reading in the cost of the item. I'll be back in 2 seconds.
Okay. Item of the name. What? Dixalius, you just got home. Cassandra, I meant. The less abstraction a language got, the easier it is for me to find errors for some reason. Even C is too high. Bro, you're definitely trolling. You're definitely trolling. Or it sounds like there's just a skill issue. Cost of the name, bruv. Enter name of the item, enter the cost of the item. Cool. Int. That only works for strings. So let's restart.
The way, yeah, you just use std sin there.
Yeah, but for consistency reasons, shouldn't we use sin at the top as well?
What do you mean?
If we got sin here, line 38, we should do it on line 34 as well.
So if you do that, then it will only read in one word of the name. So we want to read in the entire line of the user input, and that's what getLine does.
Oh,
But obviously, there's no multi, space names for integers. You can't type in like 1 and then 0 and then say that's 10.
All right. I didn't actually know what getLine does. I thought it was an exact copy of sin.
Yeah. You can use getLine to read an entire file in about 3 lines of code.
Hey.
I'll show you that in the chat.
Const item reference. What?
They're move constructor. It's called a move constructor. So
Move.
that's when move constructor.
What?
No,
What's
you
it?
want to you
What?
want to know what a move constructor is.
Yeah.
So it's a way of constructing an object using a temporary instance of it. So you remember about L values and R values before?
Yeah, yeah.
So that's the way of constructing an item using the R value. So okay, so imagine we've got a class for storing items in a list. It's like a vector class.
Yeah.
Now, the vector class will have a constructor which allocates memory, and a destructor that frees the memory. And if we were to try and copy it, well, do a move constructor actually. We'd have to type in vector new vector equals, copy it. Or actually, vector new vector, like parenthesis or another vector. It's and that would cause an allocation in the temporary variable, and then a destructor, and then they would destruct it. So you'd lose the data before you've had a chance to copy it. But what a move constructor does is it takes ownership of what you're passing in. That's probably the simplest way of putting it. Actually, a move constructor just takes ownership of it.
Okay, that makes sense. It takes ownership before it deletes it.
It literally just takes ownership of it. So it means that it won't delete it once the temporary item goes out of scope, because the new item will own it and it will handle the deallocation or the destruction of it.
Yeah. Oh, we got another C++ fan in the chat. H3. Opposite of original.
Try and run the program and see what happens if you type in a negative number for the cost or give it an empty string.
I'll try normal values for
Yeah.
the first one. Okay, and then negative. Wait,
What's happened there then? Have you?
it does not exit gracefully.
Let's abort that and let's have a look at the printing it out, because I think there's a mistake there. So okay, you want to have a new line after the cout. And the same for the name as well.
Why?
So that's on a different line.
Yeah, I get that, but why?
Because before it was printing out enter the name and then enter the costs on the same thing. Why is it saying that? enter the name of the item, enter the cost of it. It's not like giving you a chance to type it in.
Even a simple program can have crazy errors. Enter name Apple. Cost 6. Whoa.
It's saying enter the name and then enter the cost without going through the process. That's really weird.
H3 in the chat asked if I paid for you.
No.
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 Jamie is just a very kind person who offered to give his advice out.
Yeah. It's better than doing nothing all day.
He's H3 is asking why we got /n in getLine.
Because you want to read the name of the item until we press the enter key. That's the new line.
A vivid nation. I want to do software development, essentially. So back to this error. It's printing out twice.
Yeah, that's really weird.
So actually, I'm going to do another test. A, 1, B. No, okay. So even if we put a string or an integer for this input here, it still doesn't work. So let's check. So this is all fine. I think there's something wrong with this.
It won't be that. It's because the problem is in printing.
No, okay. So this is fine as well.
So yeah, this is what's throwing the error, but that's by design. So
Yeah.
if we go back to the main function
Oh, so it's here.
and add a try catch. So if we have a try catch, yeah, and obviously put all that stuff there. Yeah, perfect. Then have a catch for the runtime error. We can just print out the runtime error. But we need to tell it what type of error it's catching. So you just put a parenthesis and then runtime error. Got to be the same. It's a standard library thing, so yeah, be SCD. Yeah.
Okay.
And you also want to give the runtime error a name so we can get what it is that, the message of the error. Yeah. And then you can print out. Oh, you don't want to throw it again. I mean, you can do that in some situations, but it's not needed here. You can just, yeah, SCDC error, perfect. Yeah.
I learned that from learnc++.com. So finally
Yeah.
came in useful.
Yeah, STDC error is very good. Yeah. You can't print out the error just on its own like that. Like that, yeah. There's a .what function. It's literally just .what. Yeah.
Oh.
You want a new line after the error. Print out the error.
Do I print a new line?
Yeah. What on earth?
Bad variable
Okay.
name.
So after you print out the error in the catch, go back to the main function and type in scd cin. I think there's a way of clearing the state. So it'd be a method on the cin. Not clear. Yeah. All right, try again. Try another program, yeah.
Bad name variable.
Okay, well, at least it's not repeating itself, in the way that it was before when you had an error. So it's working there. Enter the name of the variable. For some reason, that's being problematic. Users item, yeah. Okay.
Yeah, I'll try debugging it like this way. Not sure what it's gonna do though. I mean, I can. Where is it? I can watch it. So. Oh, I need a breakpoint. Yeah. Okay, we'll
Hello?
try that.
Gabe,
Hello?
this is a reminder to read chat.
Hello? What'd you say?
Could you hear me?
Yes.
This is your friendly reminder to read chat.
So what was the last two words?
Read chat.
Read the stack.
Chat.
Oh, chat. Oh, okay. Thank you. We should
I
try
wanted to see what
catching
happens if
errors
you.
by reference and not by value. That's what someone says.
Yeah, you can do that. Yeah.
We got a breakpoint. I want to watch. That's here it is. Okay, so users item name and then users item cost. Error reading, yeah. So if we just do that, right, and then
You've got to step it for each line.
boom. Apple. Oh, right. You're gonna let me type? Here it is. Okay, so it stores the string there.
And that's set to Apple. Okay.
Users item cost. Yeah, we're initializing it to 0. Enter the cost 5. Okay, and then enter. Then it works like that. Yeah.
Yeah. See there, it's set to 5. It goes to the constructor to make it and does a check to see if there's any problems with what you constructed it with.
Okay, so none of these errors are thrown
Okay.
so far. Back in the for loop. Oh, it might be because we're constantly doing this, remaking the variable instead of reassigning it.
That wouldn't cause a problem.
Okay, it didn't catch. Okay, so second iteration. See out, enter the name,
Yeah.
and then get. So okay, so get line
It
just
didn't even give
doesn't.
you a
It
chance.
just doesn't work. It's not letting me enter anything. It just skips past it. So it went from line 35 to 36 to 37.
That's really strange. What about after we do item my item? After we make the item clear SCDC in? Maybe there's a state issue with it.
Hmm. You can create with the keyword throw new and then the exception. Then in the throw, you can access the data in exception.
Try and remove the new line character in get line. Yeah, try and run the program now. ChatGPT says that it's keeping the old new line character. So when it sees it again when we're getting the name, it will skip it because it thinks that the user's pressed the new line character, which ends
Yeah,
it.
that does make sense. No, didn't work.
But it's still being funny.
Sometimes it says bad name variable, sometimes it doesn't.
What if we read in the cost of the cost of the item as a string, and then convert it to an integer using the s2i function?
Say that again.
So rather than just directly doing SCDC into the integer user items cost, we keep user items cost as a string, and then we convert that into an integer.
All right. Interesting way.
To rule out any potential errors.
Then
You can't do a static castle that. It'd have to be a function called s2i. Literally just s and then 2i. As in TO. S2i. Yeah.
so okay.
And s2i returns an integer, I think, so you'd have to have a copy of that. Or just pass it into the constructor. So it'll be item my item, item name, and then s2i, item plus yeah, that would do it.
It works.
That seems to have fixed it. What a strange error, I don't know why that happened. Maybe it read the integer but kept the new line character.
H3 said it could be because after you enter user item cost, you press enter, so there's already /n.
Yeah.
That's
Yeah,
what, that's
okay.
what you said, isn't it?
So I think what you could do in that case then is keep it as integer. Do it as before. So you had an int like cost and then SCDC in, into that integer, and then do c in dot skip or get. So you just read in the next the last new line character.
Okay. I wanted
See,
to.
that's not giving you an error because it's s2i will throw an error if the string you give it isn't correct, if it's not a number. So let's do int user item cost, read it through scd sin, not get line, and then after we read it, skip a character so that we're ignoring the white space. So after we get that, as soon as we read the input, so on line 41 we do std cin dot get or whatever, and yeah, that'll do it.
What does that do?
So that was so we're reading the integer, and in the input stream that'll be our 1 0 and then a new line character. And before, if you don't do the get, it will read the 1 and the 0 as a 10, but it will leave the new line character. So when it comes back to get line, it will consume that new line character. And that's why it was not letting it enter the name previously. So I think now if you run it, it should work because we're ignoring that new line character.
And we can remove this clear.
Yeah, we can do that, yeah.
Not necessary anymore. Original asks is if std string is a vector.
No, it's different. It's its own container. That looks like it's working to me.
It is working. Okay, and it's accepting bad values.
What's happening there? What have we done?
I'm
Minus
just
name.
testing out. Yeah, it works perfectly fine.
Okay.
Was that it?
There's an extra bit of the homework, and that is operator overloading.
I've never done that before in my life.
You'll learn how to do it, and it will be much easier. So rather than just doing that logic there, you can actually make it a operator. So anytime you do a stream and then the left chevron, so like right chevron, you just do std in, then the right chevron, and then the item.
So on line 50.
So first of all, we need to have an operator overload for it. So we can go to line 33 and start implementing the operator overload for the right chevron. Yeah, okay.
I got no clue how to do that.
All right, okay. So it will be std
Yeah.
iStream.
iString.
iStream, like a stream of water.
iStream.
Yep. And that will be a reference. Yep. And then operator. And then the two right chevrons. Yep. And then open parenthesis. And it will take its first parameter as a reference to an iStream. And the next parameter will be a reference to an item. Yep. And let's give the parameters names. So iStream would be is, that's as a convention, and item will be item. Okay.
Okay.
And we can implement that.
So then we like operator.
Okay. Well, first of all, we can't do it just yet until we make a default constructor for item, because item is expecting user import straight away. So if we go back to our item header file, and on line 12, just type in item and then open parenthesis, close parenthesis equals default.
Wait, say that again. Item.
Yep, item, and then a parameter list with no parameters. So just, yeah, like that. And then equals default. Yep. So that is just a default constructor. It just makes one for you. So now item can be made with a std string for a name and an int for a cost, or just blank.
Okay.
So if we go back to our main, yeah, that's it there. Okay. And we can implement the operator at the top.
At the top.
Yeah, yeah.
Where?
Same as a function.
Oh, yeah. Like that.
No, same as you would implement any other function.
Yeah. What's the type?
No, as in you literally just put an open bracket instead of the semicolon. Like a normal function, on line 39, the
I'm
brackets.
so confused. Line
Just type in a
39.
bracket. There's a bracket there, you see?
Yeah.
It's
What?
the same as any other function.
So like that.
That's a parenthesis.
A curly
Yeah, that's the one.
brackets.
Yeah, brackets.
Okay.
And what you can do is just copy the old logic from line 47 to line 54.
Line 47. That's a string.
Yeah, just copy all. Just copy all from line 47 to line 55.
Bro, I'm so confused.
So you're just implementing that logic that you did before into the operator overloading. You just move it into the operator function.
What? Do I put it on line 36?
Yeah.
Oh, you said line 54.
I was saying to copy to line 54.
So is this good?
Yes, we defined what we're going to import. We're now going to implement the logic for that, and that's from line 48 to line all that.
Oh, all of that stuff.
Yeah.
Okay. And then we can just
And
call the function.
well, first of all, rather than using stdc in that operator overloading function, just use is. And it's a variable, so it won't be in the std namespace. So it'll just be literally is chevron. Yeah. And the same wherever you see it in that function, it should just be is rather than cin, because we're using is rather than cin.
Okay.
It'd be same for line 43 there, it'll be just is. Yeah.
Yeah.
And then afterwards, we'll just say item equals a new item. So you just can construct another item. Yeah. And then you're going to pass in the user item name and the cost. Yeah. And then the function will return is. Perfect.
We don't need that
So now we
anymore.
can just make a blank item and just call it item, and then just do std sin, same as you would get an integer, just std sin, and then two right chevrons into the item, like that. That's perfect. And it will read it, but it won't print it because we haven't added that logic yet.
Okay, it does work.
Perfect. And because iStream is a class that stdcin inherits from, as does file streams, if streams, it would also work for reading it from a file.
All right.
So because you use operator overloading, you can read it from the keyboard and from a file stream. It will be the exact same logic or code. You just make a file stream object and then do a file stream to write chevrons into item and it will work.
So if we want to read from a file, it'll be the same logic.
Yeah.
Sick. All right, I get it. This is some complicated stuff, though. I can't lie. Right. All right. And that is it, isn't it?
Yeah. All the operator overloading is just letting us use the logic there without. It's just really hard to explain, actually.
I bet.
Yeah. So you're just assigning the logic of the operator to do that there for that item. That's why it will work for any iStream. So a cin will work, if stream will work, maybe even string stream will work. So you've saved yourself a lot of coding just by doing that, because otherwise you have to do it for every single different type.
Yeah.
So in doing that, the code is more expressive. Because you can see there, all that logic is now just literally std sin into item.
Yeah, that is it. So we've overloaded sin.
We've overloaded the right chevron operator, which is called the insert operator.
Okay.
You can now make it read from a file, and it would work. You could also do an operator overload for O streams. So you could do literally std sin write chevron into item and then print out OCL just by using the chevron. It will be the same sort of function, except it would be std O stream that you're returning as a reference.
Yeah, so O stream there, that's it.
Yeah.
And take an O stream as well there.
Yeah, you can just copy it and do. Well, I mean, you've just got rid of the old. You're getting rid of the old function there. You should just go make a copy of it.
This is getting really complicated.
No, it's not.
But-
Don't be afraid of it. It's all right. You can just copy the function and we'll modify it to work for O streams.
An O stream is what?
So
Fine.
an I stream is an input stream, and an O stream is an output stream.
So what we
So
put on the
C
terminal.
in. Yeah.
All right. So this would be
And-
for C out.
Yeah, things like C out, yeah. And rather than it being a right chevron for the O stream, it would be the left chevron. Because that's like we're putting it into the output stream. Yeah. So it would be left chevron. No, think about the logic. We're just outputting it.
Oh, I didn't mean to do that bit. So
No. In this function, we're literally just outputting it. There's no input in this function. We're just outputting we're just outputting the item. So it would be literally just OS name, item.getName cost, item.getCost.
So at this point, in this function, we already have the data, so we don't need to do this.
Yeah, we're just printing out the item.
Yeah. All right. And then like that.
Perfect. And let's make the item a const reference rather than being a changeable reference, a constant reference like that. Yeah, perfect. So now on line 68, you should be able to do std cout, and you can see out the item. And that should work. You've got a breakpoint then, so I think it will stop.
No, it's fine because I'm just running it without debugging.
All right, okay.
Cool. Original says he thinks it would be easier to just manually implement, but I think this would be good for if you have a lot of stuff to like input and output. What would the answer be?
C++ is always better than C. That is my pragma. C++ is always better than C.
No, but I
And
mean,
the way the C++
he's talking about the operator overloading thing. He says it would be like easier to manually implement.
No, it wouldn't. You'd have to do it for every single type. So because you've done this in this way, you've got the power of reading it from the input and sending it to an output file and a console out and any other O stream or I stream without implementing a function specific to that. So you've got a lot of power right now by doing this. And you can literally just make a file stream right now, an std off stream, and write to it and it'll work. There is no situation in which C is easier than C++.
No situation, huh?
No situation.
Oh, original says I misunderstood what he said. Alright, it's fine. Anyway, yeah. I think
So Gabe,
it's cool though. Yeah.
Yeah, it's cool. You can now make an SCD off stream. It's bestly named output file stream
Yeah.
in the
Yeah,
main
off stream.
function and write to it.
Yeah, I used off streams many streams ago.
Right. No, you need to do that. You've already implemented it through the O stream operator overloading there.
Yeah, but
Because
this takes item.
Yeah, it does.
But
So what's
the
the
text
reason why
file.
you're trying to implement it that way?
Like if you wanna like output the text file.
It would still work. You didn't need to do anything extra. Except
What?
from initialize the output file.
But the output file doesn't have type item.
So the way to read that file, that function would be this this O stream called OS is outputting this item called the item there. So if you look at line 69,
Yeah.
C out would be OS, and the item there will be the item in the argument list.
Okay. So what for the OF stream?
You just make an OF stream, point it to a file like say, my output or txt, and then you can write to it. I would do it at line 62, so you're not opening it and closing it every time. Yeah,
But we don't have the data yet.
that's fine. We will make the data. Yep. And you need to include the F stream header to get that to work.
Forgot about that.
Okay.
And then
And on line 72, you can just type in my output file, and then just do 2 left chevrons. You don't need to make it a dot there, yeah, perfect. And then this item. That works out of the box. So if you run that now, it will make a output file and write to it whatever you input in the same way that you've defined it in line 51.
original's lost again. Okay, I finally understand more about what you're trying to tell me. So we are using this output thing, OF output for the item object. Would output that to a file. But I was thinking in a more general sense, like we could just use this new operator overloading to just read and output to a random file without the item. I don't know. I was confusing myself, but now I know that we were just talking about the item object.
Yeah,
So
yeah.
it makes sense now. Okay. So yeah, let's try that one then. Just work out of the box. So
Yeah.
Apple 5. And then I want it afloat though. I want some decimals. And then we've got banana.
Five 5990 Ti.
We need a way to gracefully exit the program.
Hit Control and D.
Control D.
Yeah. Think that'll do it.
Okay. I'll check out if the file got outputted.
Being learning C++. There it is there, data.txt there.
Ah, sick. There's nothing in here though.
Nothing. Oh, so let's have a look there then. Oh, I think I know what's happened. You haven't flushed a file. Okay. Right. So on line 73, make another chevron to the left and just type in SCD and L. So after, yeah, that'll do it. Yeah.
So it just got to be flushed.
Yeah.
This language is so crazy.
It's very powerful. Yeah.
Nothing compared to Python or anything else I've seen so far in my life.
Good.
All right. And that's all.
Yeah.
I
Yeah,
wanna-
I'd say so, yeah.
let's continue with the HTTP project now. Warm-ups
Yep.
out of the way. That was very nice.
I'm going to head to the toilet. Be right back.
Sorry?
I'll be back in a sec.
All right. Cool. So going back to this HTTP server, let's see where we're at. So this is the server, it's the client. Hello. Okay, formatting's messed up. What on earth is going on with this formatting? Welcome to server. Oh, I'm in the server. So okay, if I go to the client one now, that will make more sense. So, and 2 messages to send. Okay, line 78. Hello. Server responding. Welcome to the server. So it's formatted nicely on the client, but on the server, put the message out here. So what we do, go back to server. Right. So where is it outputting this data? So the colon here and says, the says word is here. So the data is in IP. That makes no sense. It says apparently the IP is storing the actual like buffer, the actual data.
All right, Gabe, I've got to go for about 10 minutes. I'll be back and we'll carry on.
That's alright, man. Take your time.
All right. Have a look into threading because we need to have the accept on a thread so it doesn't block the rest of the program.
Threading, okay.
Threading, yeah.
Alright.
All right. I'll be back soon.
See you, man.
See you.
Look into multi-threading soon as well. I just want to fix this formatting. So I'm guessing that I don't know why this IP that's storing the actual data. So okay, if I just remove that. Try again. Okay, so we got the port. Don't know why the port that was not there last time. What? What? That was not there last time. Okay, let's do some testing. So test on line 118 outputs right before the IP stuff. Let's see, maybe the constructor is messing everything up. No, don't make a difference. Yeah, okay, that's it. IP is actually the message. Whoa, that is so weird. That is weird as hell, right? So then how do we get the actual IP? So we've got the port, but we need the IP. Socket address. Socket address. No. The IP is always the same, really. Socket IP. Ah, alright. Hello, Linux. How you doing? Hey guys, stop fighting over the crown. It's not worth it. Ugh. I can take the crown back in 1 second if I want. Mwaha. Right, I'm gonna put music on. Because it's just me now. Hopefully it's good music. I never listened to it before. And hopefully it's not copyrighted. Let's see, how does the stream hear it? Hopefully it's not copyrighted. Let's see, how does the stream? Hopefully it's not copyrighted. Shut up. Okay, good. Linux, you didn't answer my question. Do you want to get banned? I think Linux wants to get banned. What do you think, Original? Can't find music I like. I might just raw dog it, go no music. Oh, this one. Alright, this one's good. I'll leave this one on. The question is, how was your day? Okay. So I think that. Yo, Moki Moki, what's good? What's good in the hood? Your day was good. I'm glad. What about mine? I went to college for one lesson and then I dipped. I should be in college right now, actually. But it's alright. I prefer C++ over college. Basically, I think I know what's going on here. So, I'm making a variable IP with the actual IP. But then I'm reassigning, I'm making a new variable called IP as well. So that's the buffer. I don't know why I named the... Yeah, this don't make any sense. IP, right? It actually... That's the thing that gives out what the user inputted in the client side. But for some reason, it's called IP. I don't know why I did that. So I'm gonna call it something else, right? Mic just fell off my balancer. You see all the references. 1, 2, 1. Yeah. Okay. So I'll just rename this then. So user input, client input. And then I'll put that there. And then I'll put IP there. And I'll also put the colon there. So IP at port this one says this. Okay. I hope that's the solution. Let's try it out. Let's try it out. Okay. Yeah, that's it. What? What? Wait, what? Oh no. Bro, the microphone's so cooked. I keep slapping it. Oh no. It's falling now. It's all breaking. Sit. Okay. I just need a new line. Why are you saying the IP address? Why on earth is the IP also printing out the actual message? I need a professional to come back. I'm gonna put this on GitHub in a minute. Okay, so everything's good so far. But when I type the message, oh, it works. Okay, I don't know why it works. I have no idea why it works. It just works. Bro. This shouldn't work. This should not work. Oh. Ah, wait, I get it. I did not see this little see out buffer at the end. This little sneaky one-liner on 138. Oh, bro, I didn't see this. So this was the thing that was messing up the format. Okay. Okay, buddy. And I'm just gonna put the buffer here. Okay, I don't need that anymore. Right, let's see if this works. No. Okay, I guess we gotta leave it up there. Although it should work. Oh no, it's because I didn't end the task. Okay. So if I take this and then I put it down here. And then basically I'll just do that. Now it's all better, it's all good. Output what the client said. Okay. Enter your message to send. Hello. It works perfectly. Absolutely perfectly. Nice. Oh, I'm glad. I'm glad I finally fixed the formatting after 2 streams. We've got 3 new lines here. Why not? I don't know why it does that. That's an issue for another time. Adding semicolon in comments, real programmer, yeah. Oh, that's just force of habit. Oh, I didn't even realize I did that. Yeah, force of habit. You know, when I've been writing Python code recently, like off stream, I've been starting to add semicolons at the end. So I'm doing like, I do that. And it's starting to really mess me up. This stinks of monster. So if I just run the binaries, magic ball up. Wait 1 sec. I get distracted so quickly. Crazy. So if we go here, let's see if we can run 2 at once. So we've got server listening, client, all good. Hello. Now let's see if we can run another client. I don't think we can. No. No, okay. So this is the part where we need to introduce threading. I understand the concept of threading, but I've got 0 clue how to do it in C++. So Yeah, so somehow it connected to the server. It's waiting for, this second client is waiting for a response from the server, but it can't do that because we have not got multi-threading. It's currently just talking to this top client up here. So yeah. And when I do multi-threading, I'll just add nicknames as well for more prettiness and that. But yeah. What is this music, man? We've got some lullabies going on.
Hello.
Hello.
I could teach you threading, but I think since you're doing it in C++, and I don't know the syntax for threading in C++, probably better we wait for Mr. Question Mark to return.
I mean, do you know? Can you give me a tip for where I can start?
What do you think of when you hear the concept of threading? And bring up the, what's it called? Control. It's a task manager.
Yeah.
What's it called? Control. It's a task manager.
Yeah.
Under, I think, performance and CPU. Do you see what it says threads there?
We've got 4,240 threads.
Yes, that's all your applications, individual threads.
All right.
So a thread is literally just like a line for the CPU to follow. Like how whenever you create a program, you're creating at least one thread. If that makes sense.
Yeah, one thread by default.
So it's basically the CPU will run the available threads unless it's told otherwise, until they're completed, right?
Yeah. That makes
Does
sense.
that make sense to you?
Yeah, it does.
Like if you think about when you compile a program, it runs until you tell it to return 0 at the end of main function, right?
Yeah. So is there a maximum of threads you can have in your program or in your computer?
No, but at one point it's like the addition and creating of threads is like more expensive than whatever whatever else option you're like trying to dodge by creating a lot of threads.
Yeah.
And you have the problem of what's the issues with keeping an application multi-threaded. Have you heard the concept of a race condition?
No, never.
Bring up Paint for me.
Bring what?
Bring up Paint for me.
Paint, alright.
Divide the screen into two parts with like a fixed line or something.
What? You mean like this?
Yeah. I want you to imagine the left side. Zoom out so we can see the entire thing. In like the Paint window.
Like this?
Yeah, I think you zoomed in. So just zoom out. Oh, why is it so long? What did you do?
I don't know. This is how it is by default.
Anyways, divide this one into two equal parts.
So equal parts, alright. I'll make this a bit shorter as well. Oh, real quick. I just want to show original that the CPU can get to 5.1 or 5.2 gigahertz on idle. It might not do it now though because I've got lots of apps open. Alright, it's not doing it. Anyway, yeah?
So I want you to imagine the left side is thread 1. So let's title it that by writing at the top.
Yeah.
And on the right is thread 2.
Okay.
Until you tell the computer otherwise, it will continue to run until it's returned the end. So write return 0 at both of them.
At the top.
At the end. At the bottom of each column.
Beautiful handwriting. Right. Return 0.
So now fill this with like garbage code. But make sure at some point reference the same object or like the same variable instance of an object. Be more precise.
So should I make one integer, for example, that they're both gonna share?
Yeah, exactly.
So where do I write it? In thread 1?
Like one of them creates an integer called a, and the other one tries to access it, or they both try to access it at some point in
At the
code.
same time.
Well, that's the funny part. What do you mean when you say same time?
For I don't know. Same time.
I am a bit rushed for time today, so I'm not going to get into the entire physics of how time works, but it is technically relevant to the conversation.
No. It's alright.
So if you just find yourself having a spare evening, just learn how time works. It's very interesting.
How time works.
How time works and how we can, for example, it's very hard to measure things accurately, but for smart ways you can figure it out. Let's make thread 2 add to A at some point.
Yeah. Oh, 1 sec. I got to reply. So Atharv. Bro, what are you learning C++ for? I want to be a software developer, software engineer. That's essentially it. Yeah, Linux. Sorry, not Linux. Cassandra.
Yeah.
We added it.
Let's add it on the left side as well.
On the left or right? So before or after C out?
Let's do it after. Or during.
During?
Let's C out A++. No, let's do plus plus A instead of... So on the line above where you have... Yeah, exactly there. Just do C out. Let's do A++. So you can imagine the computer has 2 threads, and it will process each of them whenever it has time. The way it works is very like it's flip-flop between all of these threads. Like as you can see, you have 4,000 of them open at the moment, and one of them is created and closed just as your computer runs through the day. So the one of the issues that can arise when you're dealing with 2 threads with the same data is something known as race condition. So I want you to break down what you think A++ does for me. Like fundamentally, like at the machine level, what does A++ mean?
So accesses the A value, gets the A variable, it gets the value, it increments it, and then it stores it back in A.
Right. So we have 3 operations that we make. We have the retrieval, we have the increment, and then we have the set, like the return. That we're changing the value, right? I want you to imagine what this function does. Like if we have these threads in a program, and what happens if thread 1 runs completely before thread 2, and what happens if thread 2 runs completely before thread 1?
Well, A is just going to be 1, but if we run both threads at the same time, A is going to be 2.
Yes, but what happens when the order changes? So let's run through thread 1 completely first, and then thread 2, and then let's do thread 2 first, and then thread 1. Play the compiler for me and just pretend like start at thread 1 at the top of thread 1.
All right, so making
out the
A,
first line?
setting it to 0. We're adding 1,
Yeah.
so A is 1, and then we're outputting A, which is 1.
So we're outputting 1, and then we're running thread 2, which does what?
It just does 1 plus 1, 2.
And returns 2, and it does nothing, right?
Yeah, it does
Let's now
nothing else.
imagine this scenario where thread 2, because of just how the compiler works, and it just randomly got into thread 2 first and started doing thread 2. So what happens when A++ is called?
When A++ is called,
Yes.
gets a value, increments it.
Except what value do we get?
Oh, well,
We haven't declared A
Oh.
is equal to 0 yet.
that would be an error.
Yes. So
Yeah.
this behavior is called undefined behavior. We don't know exactly what would happen. Depends on like the compiler, the operating system, a lot of factors. But
Yeah.
let's imagine we start in thread 1 and we do A is equal to 0. Then thread 2 runs, because sometimes the CPU will just pause threads and go like, you have to wait, I'm just going to do other stuff, and then I'm going to return exactly where you were when I get back to you.
Yeah.
So let's say it starts doing the first, it does A is equal to 0, and then it jumps over to thread 2 and does A++, and then it continues back into thread 1.
Okay, yeah.
And then it prints it out, and now we have a function that depending on like fundamental, like completely random elements that we have no way of controlling or predicting, this like set of two functions will either print out 1, print out 2, or crash and burn horrifically.
Yeah, it would, yeah.
So this is something known as a race condition.
Race, how do you spell that?
We also have a race condition within the A++ as well. So let's imagine we start with A0.
A race
So we just
condition like
declare
that.
it. Yes. And let's break up A++ into its separate things. So there's a retrieval, there is an increment, and then a set.
Yeah.
So let's imagine the incrementer in thread 1 runs first, but then before the set has happened and the increment and the set has happened, thread 2 does its retrieval.
So we do the first 2 lines in thread 1, and then the first line in thread 2, and then we output.
No, we don't do the first 2 lines. We do the first 2 or the first 1 and the third line. So in the A++, we only do the retrieval of the A. We don't do the increment or during the increment, but particularly before the return and the setting of A to 1. Thread 2 can start its retrieval of A, which at that point will still be 0, and then we'll increment it by 1, and then we'll set it as well. So we have both of these plus got ran, and we could have gotten either 1 or 2 depending on exactly how the timing of that order lands. Does that make sense?
Yeah, a bit.
So you're gonna get introduced to a concept called locks. So we can just right before A, if you can just like squeeze in some text before both A's, we're just gonna make sure that the lock for A is unlocked. Which you typically do. I don't know how it's called in C++, I assume it's just called lock. So like no, but after the a is equal to 0, but before the a plus plus.
Okay, I think I'm gonna write it all out again. 'Cause it's getting really messy. One sec. I'm gonna get Epic Pen. Oh, what is going on here, man? Yeah. Cool. I'm just gonna write out again. Right?
If only it was something you could write on your screen, like a paint or something.
Thread 1. Thread 2. So then, yeah, int a. And what do I do after that?
After that, you call a lock.
Lock.
So you just call lock and then the function of input a as an argument is typically how it's done.
Is that a real
like-
function?
Depending on what syntax, it's gonna be different things. Like in C#, we just call an empty object and then we just use that object as a lock.
Okay.
So I'm assuming it's in C++ is gonna be something similar, but just lock a makes sense. Like we're just locking a, and then we
Yeah.
don't. This is just pseudocode.
Yeah,
and it's not
pseudocode, yeah.
actual code.
In pseudocode, it makes sense. Okay. And then we output it.
Yeah. And then we a plus plus, and then
Oh yeah, I
output
forgot about that. A plus plus.
and then we're going to unlock a.
Unlock. Oh. So unlock that allows us to use it.
That allows us to lock it again, and if someone else tries to access a now, they can. And depending on the
Yeah.
implementation, it's typically the function or the threads are just gonna wait until it gets unlocked, and then that's one of them through at a time.
Yeah. So unlocking allows us to use it in cout.
No, but it allows it to use it in the other thread. You could see out before you unlock it, but since it's just a get, it shouldn't matter. But if you want to ensure exactly how it works, then it should be inside the unlock. Sorry.
So on thread 2, I would unlock it.
No, it's already unlocked. We assume, or if we, what do you call it? You start by checking the lock phrase or lock a.
Like with an if condition.
No, just a lock. The lock is an if basically. Just write the lock just as you did on the left.
Oof, this is right. It's awful. So lock, right? That's it.
Yes. Lock of a. Now we're just gonna ignore the fact that we're not properly checking that a is initialized. We're just gonna ignore that for now. Typically, you would handle that by not initializing stuff like this, like initializing stuff that aren't thread safe, you know?
Okay.
Like you do it before you start launching the threads or like in conjunction with starting all the threads. Does that make sense?
So you'd do it out. You'd initialize
If we have
it
two threads
outside
and
of
want
the
to
threads.
use the two threads to work with data, we're gonna have to always make sure that data is initialized first, right? So in this example, in this pseudocode, it's just an issue, but we're just gonna ignore it for now and just a plus plus in thread 2 and then unlock it again.
All right. One sec.
So on the right side in thread 2.
One second. What is it? What's up, Pawan? Board Game Maker says the problem is both threads can retrieve the value at the same time, and they'll both have their own local copy. We'll end up with two one
yes,
values.
that's exactly right.
They both write back to A. But log ensures there's only one thread that can access the variable at a time.
Yes, exactly.
Oh, all right.
So basically, can you finish writing log 2 and I'll just quickly give an example before I have to go?
Yeah. Well, so in thread 2, what else do I write?
A++.
Yeah, A plus. Oh my lad. What is this? You're not that fat before.
The big black dot right here. And then unlock. And then return. So if you simulate the code now, we're going to start thread 1 and 2 simultaneously. So we're going to declare A, and then we're going to lock A in thread 2. And then thread 1 is going to advance to its lock, and it's going to say, okay, this is locked because someone called lock already. So I'm going to sit here and wait. I'm going to pause myself. So I'm going to sit here like, hey, I'm to like to Windows. Hey, I'm waiting for this variable when this variable is false. I think it is. I want to become active again. So whenever that's true, just wake me up again, and I'll continue.
Okay, so would each
so
thread be in a different file?
Not file necessarily. You could have a thread, multiple threads spawn out of the same like from the same class, basically.
Oh. All right.
So we're gonna continue in thread 2. We're gonna add to A. We're gonna wait in thread 1, and then we're going to unlock, and that's gonna allow thread 1 to on its next pass to continue with the A++. Then we're gonna continue in thread 2 and we're gonna return 0. And then we're gonna get back to thread 1 and we're gonna unlock it and see out it and see out 2 and then return 0.
Yeah. That makes sense.
Yes, Linux. So therefore you have to make sure that like to keep your data clean, if that makes sense. So to know I'm only touching this variable with this thread, or like make sure it has a lock, basically. So you do that at like the development stage of a like when you're sketching out of like these are the functions who's gonna have these responsibilities, gathered under these names. You typically drop which thread is responsible for what, to make sure to like you don't ever really want to touch that. It sort of sounds dumb since threading is all about keeping separate threads, but you want to keep it to as few threads as possible and keep the data that each thread has limited to itself, if that makes sense.
All right. I think we can start implementing it then. This test.
So you could probably look it up yourself how it works. I have to go in 5 minutes, or probably less than that. So probably jump off now. But do you think you have a good understanding of the subject?
Yeah, you definitely taught me quite a bit. I definitely have a much better.
So this is basically all threading is. The only problem now is all of the issues that arise when you start locking things. So the entirety of knowing how threading works is partially knowing how locks work, and then all the issues can arise with a lock.
Fair enough. Well, I'll get to that bit.
So I'm
when-
gonna wish you good luck. I might turn in and like watch every now and then. But best of luck.
All right, thank you. See you
Bye
later.
bye.
Bye bye. Welcome NASA. Welcome. Would you kindly and William. William, brother. Why don't I just use Rust? There's std thread header. Yeah. I think that is the header, yeah. So we're gonna need the header in the server. We're not gonna need threads in the client code. So let's see. Let's see. Include. Spell it right, please. Threading. No. Let's see. So let's hope my computer doesn't blue screen again like it did yesterday. Or the other day, whenever it was. Yeah, it was the other day. Okay. Thread name, right? Let's create the head. The thread header, yeah? Okay, I put threading. But whatever. Thread. Close enough. The thread class represents a thread. Threading an instance of this class will create a thread with the given callable as its task. Also, guys, tell me if the music is good. Tell me if it's like good enough. Audible. That's the word. Okay. Athrav, by the way, I know I'm responding late, but it's cool that you're doing it for finance. That's really nice. Who joined? Oh, Jamie.
Hello, Gabe, it's me.
Jamie, what's good?
Everything's good. Just a nice Rustler's burger.
You what?
I had a nice Rustler's burger, microwavable burger. Rustler's burger. Yeah.
Rizzler burger. Okay, nice.
Not Rust as in that abomination of a programming language, but Rustlers. It's a well-known British brand.
Oh, Rustlers. Yeah. Oh yeah.
Yeah.
That ready-made in the plastic thing. Yeah.
Yeah.
Nah,
It's
they're
one of
banging
us.
though. They're banging.
They are, yeah. Absolutely. You
No
know.
one can say anything bad about them. They're
They can't.
absolutely banging.
Absolutely. You
No.
know.
All right. So yeah.
How was the code?
Well, I didn't do any more code. I fixed the formatting. How was it? On this, so I made it look like much better. On the server side, I mean, right? So
Yeah.
if I say hello, right, it says
Yeah.
IP port says hello, right? So
Yeah.
that's what I spent most of the time working on. But wait, one sec. Speaker's broken again. Alright, good now. So Cassandra or Dixalius, whatever, she taught me a bit of how the threading works under the hood, so I understand a bit more now.
Alright, cool.
I tried connecting two clients, and as I expected, it didn't work.
Okay.
But that's completely fine. All we've got to do is just the threading, and then that's it, right? You can
Yeah.
the ports differentiate the different clients, and then people can just talk to each other. The server can see all the messages. The client doesn't see anything yet, but I'm sure we can figure that out really quickly as well. That's just basically the server is sending what other people sent in the buffer. So that would be probably pretty simple to make.
Okay. Yep.
So yeah,
Right.
just gotta add this threading. You there?
I am there, yeah.
So leverage multiple CPU cores.
Yeah.
Let's create a thread. Oh, I just deleted the thing again.
He deleted the window.
Yeah, I deleted it. Okay.
Go to the windows. There's a window bit at the top. Click on reset window layout.
Oh, okay.
Oh, it's still not there. That's weird. Oh, it is actually. Yeah, it's on the left side.
Okay. Now it says it wants a callable, right? It wants like a class or something, but I'm not sure what to put there.
That can be a function. It's anything that's callable, like you call a function, is a callable. Could be a class as long as it has the operator, the function call operator overrided.
Yeah. And I just remembered the whole point of doing this like separation thing with all the different projects was to put all of the different code bases in their own separate files, right? We didn't do that yet.
Yeah, so I can see we got in the library TCP socket and WSA. So the library is the common code between the two things. We don't want to make a different socket or write code for a server and write code for a client when we can just do it one way.
Before we can go into threading, we've got to organize this.
Sure.
So the way we can do it. Tell me if this is a good method. For all of these like different sections, I'll just put it in a different file, right? In a different function class.
Yeah. So separate the concerns. You got one concern for initializing WSA, one concern for creating the socket, and another concern for reading the input and all that. But we can definitely use that TCP socket class we made before.
Yeah. So
So we'll be using that class in the client and the server. So I think right now it connects to, well, binds to an IP address. But we also need a destructor. We create it with an IP address, and that makes a socket. But there's no logic to say when the TCP socket goes out of its lifetime, then destroy the socket. So the destructor is just for cleaning it up.
what would be step 1?
So in TCP socket, you want to have a destructor. So the way that you do that is
It's the tilde, isn't it?
tilde. Yeah, that's the one. Yeah, and then just write TCP socket. Yeah. And then you can implement that by right clicking and clicking on quick actions, and it will allow you to create a definition for it. So what we can do is just check if it's a valid socket. So we've got a member function called valid, I think it is.
Yeah.
If it's a valid socket, then we just call the close function and pass in the socket. So yeah, that's the one.
And pass in the...
It'll be called H socket.
Oh, the handle, yeah.
Yeah. That's it done. So that's the structure done. But we now need to also disable copy semantics.
I don't know what they mean.
We don't want to copy TCP. So I don't want to be able to do, well, you wouldn't want to do TCP socket equals blah blah blah, and then copy it like you. So you wouldn't want two sockets and to assign one to another. It should be totally unique and non-copyable.
Okay, that makes sense, but how do we go on doing that?
Go back to your header file. And we'll need to have a new function. And it will be like a constructor, so it will be TCP socket. And then the parameter should be a const reference to a TCP socket. And at the end, you just type in equals delete. Not in that bit, but after the parameter list, yeah. So that will just delete. It will disable copying for that class. And the next one will be a function that returns a TCP socket reference. So it'll be TCP socket reference. As in the ampersand at the end of TCP socket.
Oh, yeah. But what's the name of the function?
It's operator equals. We want to just delete the assignment operator for a copy. So it would literally be TCP socket reference operator equals, and the parameter will be a const TCP socket reference. And the operator is, you need to have a equals after operator. And you want to add the equals delete at the end of it. Like before on line 25, you want to do equals delete.
I don't get it. On line 25, we got delete.
So yeah, on line 25, we're deleting the copy constructor. We also want to do the same for the operator equals. So at the end, you just type in equals delete like before. Yeah.
Oh, I didn't know you could have two equals signs in one expression.
Yeah, it's just operator equals is just a function name. It's the same as any other function.
All right.
And we also want to implement temporary a constructor that takes in a temporary in R value. And the way that you do that is type in TCP socket and then put 2 ampersands. Yeah.
So was that name
and
again?
that's called an R value reference.
So on the right
So
side
that
of
is
the
a-
equals.
Hmm?
It's on the right side of the equals.
Yeah, that's the one. Yeah, it's just a temporary variable, a temporary object rather. And we'll also want to have a operator equals that takes in a R value reference to a TCP socket. So like line 26, but instead of deleting it, we're gonna have one for it. No, you want to keep it as was before and just copy it. Control C and Control V. No. So it will be like line 26, except you're not deleting it. So it'll be TCP socket reference, operator equals, and the parameter will be a TCP socket R value reference. Yeah, like that. Yeah. And we can give those parameters names. Yeah. So standard convention, yeah, R value, and same for line 29. All right. Yeah, we can implement that now.
We can what?
We can implement the functions now.
Oh, good.
Yeah.
So there.
Yeah. So a R value constructor takes ownership of whatever things pass into it,
Yeah.
and that means that we're going to set our H socket to the R values H socket, and then set the R values H socket to invalid socket. Yeah, perfect. And then after that, you just set the R value. Yeah. Yep. And you also want to copy over the IP address of the R value.
Into what?
No, as in we do IP address equals R value.IP address. And we don't need to worry about deleting there or zero setting there. Well, hang on, it says here R value H socket equals H socket. What you want to do for the R values H socket is set it to invalid socket. So we're taking their H socket and then invalidating it.
Hmm?
Yeah. All right. And you know before when you're using the colon to initialize the value, it will be the same. You just do you initialize it with the R values IP address. Right. And then you can get rid of the other one on line 62. Yeah, that's good, yeah. And then just you set the R value to invalid. So you can just get rid of line 62 and line 60. Yeah, that's perfect.
And set the IP address. to-
That's all done now. The
Nice.
reason why you're invalidating it there is because when that R value goes out of its lifetime, it will try and close the socket. But we own the socket.
Yeah, we do.
So even though we own it, the socket will be closed.
Yeah, so yeah, we wouldn't use it anymore after it's closed.
Yeah, and that's what's meant by taking ownership of it. So we own the socket now. So the socket's lifetime is tied to the lifetime of the TCP socket class.
Yeah.
And we also need to implement the assignment operator for an R-value reference. So if you go to your header file, you can just right click on that and click on define, I think it's called. Yeah. So here what we do is we close our socket. Yeah.
Why-
Close socket and then
Why does it say to do insert return statement?
eventually we'll need to return a reference to this at the end because as you can see the return type of that function is a TCP socket reference.
Yeah. So this does it. So Visual Studio automatically put this comment in.
Yeah, this is as a reminder to insert a return statement at some point.
Wow. That's actually cool.
So to finish off with the operator equals, we close our socket and we then take ownership of the R-value socket.
Okay. So
Hover your mouse over and see what the issue is. Expression preceding parentheses must have a pointer to function type. So it's complaining because you're treating hsocket like it's a function, but it's just a variable.
my
Yeah,
bad.
that's all right.
I'm
And
gonna
then
read that again. Parentheses of a parent call must have a. Okay, yeah. Okay.
yeah, and then you invalidate the R-value socket. And we also want to copy the R-value IP address into our IP address. And then we just return this. As in like the literal keyword this.
Oh, this.
Yeah. And this is a pointer to the current object. So we need to dereference it to get a reference. Yeah, perfect.
Damn.
So do you understand how that is taking ownership of the socket?
Yes.
Perfect.
Mostly. Yeah. We gotta allow move semantics as well.
That's what we've done.
Oh, we did
Yeah.
that right. Oh yeah, with the operator. Yeah. And then,
Because of this kind of thing in C++, it's very fast to create a new or pass a vector as a temporary if you're using a string, because under the hood it's just literally just a swap of a pointer and that's done.
yeah.
So R values make C++ very fast in a way that in a way that C cannot be fast, because C just knows what copy constructors and that's it.
You hear that original? C
He'd be
sucks.
he'd be covering his ears at this point. I think what we should do on line 66 is make sure that the H socket is valid before we close it. Because if it's not if it's not a valid socket, then it may cause a problem.
Yeah. Yeah.
Perfect.
Declare it
So
no
it says
except.
that is simply a suggestion.
Ah.
So it says here that we now need a member function for accepting a new connection, which will return a new socket. So this is where we have like a TCP socket dot accept member function.
Yeah, this is for us to use, yeah.
Yeah. So we'd have a TCP socket for our server socket, and then to get a new client, we just do TCP socket equals server socket dot accept. So it's making the socket library object oriented.
Good. That's what we want.
Yeah, be easy to understand as well, because you're limiting how much information you need to do in order to make a socket, because it's already done for us. You know, type in or AF_INET every time and all that.
Yeah. Also, Board Gamer Maker has a message for you in the chat.
C doesn't even have copy constructors. It kind of just moves by default, but doesn't zero at the source. So you end up with double free errors if you're not careful. Moves by default. No, I don't think it moves it, because C doesn't know what an R value reference is. I think it would copy it. But you definitely can get double free errors, and they're a right pain to deal with. The reason why we have these functions at zero at the source is to avoid having multiple owners or something. Yeah, that's very true, Gabe. So the reason why we've got these R value constructors is so that there's only one owner of that socket. If we were naive and allowed a copy constructor by default, then there could potentially be two owners of the socket, and if one closes that socket, then it will close it for the other one also, and we won't know about it.
I love listening to when professionals debate. It's really, really nice.
Right.
So many words. So many words I don't know about.
Yeah.
I'll learn them soon, it's alright.
So the next member function in our TCP socket class will be an accept function that returns a new TCP socket.
So in the header class we got, where is it? It returns the socket.
Yeah, it will a TCP socket called accept. Yep. And we'll implement that in the CPP file.
Alright. So let's go here.
Yep.
Boom.
And this is the part where you call the socket library accept function, not our accept function, but the lowercase accept function from
Yeah.
C. And that will get us the IP address information. So, yeah, perfect.
No.
We need to my code, because my code is very similar to yours.
We do have socket address. No, that won't work.
Let's see my
No.
code here. So we've got an accept function. Right, okay, so we need to declare a variable called client address, and its type is sockadr_in. and that will just store the connection information of the client. We'll just make a new variable at the top of the function, sock add or underscore in client address. Perfect.
We need to cast that.
Yeah. I need to put an ampersand before client address in the function call. Not there, no.
Oh, before it.
Yeah, no.
No,
So,
not there.
so we're casting it to a sock address pointer.
No, not there either.
No, before. At the end of sock header. No. Right there.
What?
Yeah. And then you want to put an ampersand before client address in that same line. Yeah, good. So you're guessing the address of client address, if that makes any sense.
Oh yeah, yeah.
And then
the
you-
reference.
Yeah, and that will give you a sock adder underscore in pointer, and we're then casting that pointer to a sock adder pointer.
Yes, that makes sense now. And then address length.
And
So size of client address.
you also need a pointer for that for some reason. So just go and make another variable called address size and set it to be equal to the size of the client address. Yeah. And then you pass a pointer to that in the accept function.
Oh yeah. We need the. All right. And then boom.
Perfect.
That's
Yeah.
it. That's it.
And the accept function will return an uppercase socket. No, the accept. No, sorry, other accept, the lowercase, the C style accept function. So on line 77, it'll be socket client socket equals accept. Not there. No, just uppercase socket like before, a big uppercase socket.
Like that.
No, socket in all caps. Yeah, and that is our client socket. That is the handle to the client socket. So you can just call it client socket and then assign it to be equal to the result of that function call there.
Then we return client socket.
You return TCP socket. Yeah, and you're gonna pass in client socket and make an address. Comma. And then type in IP address and then pass in the client address. We're gonna make an instance of the IP address class here. Right. And what's it saying? No instance of constructor. Let's have a look at the constructor. So if you go back to your header file. So there's only one way of constructing the TCP socket, and that's with an IP address. Let's make another constructor that takes in a big uppercase socket and a const reference to an IP address.
And it's also explicit.
Yeah.
We don't want. Yeah. Oh my days. And this one is.
Takes in a big socket. Big uppercase socket. Yeah. And that'll be called socket. And we also need an IP address, a constant reference to an IP address. No, don't worry about that. Just do socket. Remove those two parentheses after
parentheses.
socket. Yeah.
Yeah, 'cause we're not calling
And then
it.
an and then an IP address. Constant reference to an IP address. Not there. Right. Yeah. There we are. And then we can implement that. Why is it complaining? What's it saying? Oh, I understand. Go to your IP address. Okay, I see. So we need to have a constructor for IP address that takes in a sock adder underscore in, and we'll get the IP info from that. So in the IP address class, have another explicit constructor that takes in a const sock adder underscore in. Yep. And you can call that sock or winsock. Yeah. And then we can implement that constructor in the IP address.
Okay. IP address, so then. Yeah, so that's it. That's it.
Yeah, so the accept function will now return a new TCP socket using the result from the accept function there.
Yeah. Yeah, that's it.
But we still need to implement the constructor for IP address. Oh, yeah.
The constructor for IP address. Oh yeah, we didn't implement it. Okay, so let's go there.
Yeah, that's it. Yeah.
Uh,
So let's see where it is. Let's see, I'm on the wrong stream here. Right, where is the constructor for the IP address in your source code? There it is. Yeah, there. So first, we just the same as before with the colon. You just initialize socket address with with the sock variable.
what's the official term for that code?
It's not the top of my mind. I think it's I'll look at it right now on CP reference.
That would be helpful.
Yeah. Do you know about cppreference.com?
No.
I'll send that to you. It's just the go-to source for everything in C++.
Sorry?
It's the go-to source for everything in C++. It's got all the it's like a Wikipedia of C++.
Ah, sick.
But we want to have a look at initialization so I can get you that the name of it.
C is so much smaller than C++. Wow.
Yeah.
Wow. Alright. Now what are we actually doing inside this constructor?
So what we're doing, let's have a look, is we're initializing the IP address. So we're gonna get the IP string and the port string from that socket underscore in variable that you passed it. And the way that you do that is you make a buffer called IP buff, and its size is going to be inet underscore address string len. You know the one that's 22 characters that you're talking about before.
Oh yeah, yeah. Wait, let me find that one.
Yeah, that's fine.
Inet address string length.
Yeah.
Yes, brother. So many green lines. You know what? We're next.
So the name of that initialization that I was talking about before is called a member initialization. A member initializer. It's a nice way of initializing your variables at the top rather than in the in fact no, because if you don't do it that way, then C++ will automatically construct it for you. So say that you've got something that depends on another thing. So imagine you've got a okay, let's see, I think of an example for you. All right, so say that you've got a class for storing data, like a vector class, and that vector class depends on an allocator in order to be constructed. So if you didn't explicitly initialize it in that member initialization way with a colon, then it will not compile because it depends on an allocator to create it.
All right.
If that makes any sense.
Yeah, yeah.
So now that we've got the IP buffer, we want to call the inet underscore ntop function to get the data from it.
Size T is unsigned long, right?
Yes, it is, yeah, on most implementations of a C++ compiler.
Okay, nice.
Pass in size of IP buff.
That's it.
Yeah, perfect. And then we want to set our IP string to equal std string, and you want to pass in IP buff as the first parameter.
IP string.
So you, yeah, and in the IP address class, you got the variable std string IP.
Yeah, but that's in
So
the
we just go and
other constructor.
no, look in the header file. It's a member variable, the IP address.
Oh yeah, there is, and we access
Yeah,
it
yeah.
with the get socket address.
Yeah. So we're gonna initialize that in our constructor there, using the IP buff. So it'll literally just be IP equals std string IP buffer.
Oh my days. Sorry, what? std string.
So you want to pass in IP buffer. So you're constructing the string just using that buffer there. Yep. And then you want to initialize the port to be equal to N2 HS, and then pass in the WinSock SYN port parameter member variable. So it'll be sock.sin underscore port.
NTOS. That is, what? Something to handle.
Something strange like that, yeah.
What?
I don't know what it stands for, honestly. NTOHS. What does it mean? HTONL. NTOH. Oh yeah, it's a byte orders. Yeah. So over some networks, bytes are sent in reverse.
Yeah, because why the
So-
hell not? You know, why not? Okay.
Yeah. So the TCP TCP socket. We need to create a constructor for that. If you see, we've got a constructor we haven't implemented yet on line 24 of the header file. And we can just do member initialization for getting the socket and the IP address, or for initializing it.
The colon stuff.
Yeah, that's called member initialization. All right, cool. That's constructed on because we've initialized those two member variables. Now we need a function for sending data and another function for receiving data. So the first function for receiving would be std string receive, and the first parameter would be a const int called max bytes.
Wait, std receive.
It would be std string.
So that's the return type.
Yeah. And it will be called receive, and it will take a integer parameter called max bytes. And this function should not modify the calling object, so you can put a const at the end of it. Not there, at the end of the... Yeah, just there, yeah, at the end. Perfect. And we also want a send function. And to send will be a function that returns an integer. And its first parameter will be a const void pointer called data. And if you don't know what a void pointer is, it's a pointer that can point to any data type. It's just purely a pointer. It's got no sort of knowledge of what a type is. It's just a pure pointer.
Okay. It's good but dangerous.
Yeah, it can be dangerous, yeah. Because if you don't know what it is and try and cast it at something else and call a member function, it can cause all sorts of problems. So you've got the data parameter. The next one will be the size of the data in bytes as an integer.
Like that.
Or the size of data. Yeah. Yeah. And the last parameter is a const reference to a TCP socket called destination.
Yeah.
Yep, all good. And to help us, we'll have another function, also called send, that returns an int, that takes in as a parameter a constant reference to an std string called data, and the last parameter also being a constant reference to a TCP socket called destination. And all that the last one will do is just call the other send function, just in a more easy way.
Sick.
So the line 35 function is just for sending any generic data, and on line 36 we just make a specialized version of that.
Yep.
Okay. Let's have a look at my code and see what's going on there. Receive. Let's have a look at receive then. So first of all, if the
Hello,
handle to
Elray.
the socket,
I'm just saying, hello, Elray from the chat.
Oh.
He's from Mexico. Yeah, you were saying?
in the receive function, we want to check if it is not valid, then we want to throw an error saying receive called on an invalid socket.
We're throwing it.
Yeah, you're going to throw a runtime error saying there's a problem. Maybe be a bit more specific, saying or invalid socket. Yep. And after all that, we want to have a string for our buffer. We're going to receive data into. And we want to resize that buffer to max bytes.
Wouldn't it be of type car?
No, it'd be a string.
How do you set the size of the string?
Call buffer.resize. All good. Right, perfect. Then we're going to call the receiver function recv. Okay. And the first parameter is the socket, and the handle to the socket. The next one is a pointer to the data of the string, so that's buffer.data. And after that, it's buffer.size. And the last parameter will be 0. That's our flag.
We don't need any flags.
No. What was it? mboob causing problems before. We don't want
Yeah.
any of that.
Yeah, that's it.
Okay.
And we're going to store that receive value in something. Or we could just return receive.
No, I don't think we need to.
No.
So right now we receive data from that other. Hang on, receive. Let's have a look. Yeah, we're receiving data from the socket, storing it in the buffer, and then we can simply return the buffer. Yep. Oh, yeah, all good. Yeah. And then we can move on to our send function, and that's very simple. You're simply going to return send, and the first parameter will be the destination HSocket. Next parameter will be data converted to a const char pointer. The next parameter will be the number of bytes that we're sending.
Wait, destination is red.
Where is it?
So I have to dereference it.
No, don't worry about it. Let's see. What's the issue here? Let's have a look. Oh, destination dot HSocket, because it's a C function. It doesn't know about our types.
Yeah.
Yeah, perfect. So the next parameter after that will be the data converted or cast to a const char pointer. Const char. So yeah. And then it'd be the number of bytes. Yeah, size of data. And the flags will be 0m. Okay. And the next send function for our string, we're going to call our send function. And we're going to pass in data.c_string. Yeah. Next parameter, data.size. And then it will be the destination. Not the HSocket, just the destination, as it is.
Oh yeah. Because it
Alright,
takes
cool.
in the TCP socket.
Yeah. And that is our TCP socket class done.
Wow, is it?
Yeah. You can give it a test so you can actually see if you can implement that, or you use the TCP socket class there rather than doing all like these C-style calls everywhere. Well, actually, we need a listen function, don't we?
Oh yeah.
For TCP socket. Let's see.
We don't have a bind one either. I don't think.
Let's have a look in the sockets. Let's see. Okay. So in the TCP socket constructor that only takes an IP address, we're going to bind to it. Or in fact, no. I think we should be a bit more specific. Let's have a bind function
Yeah.
and a listen function.
Yeah, I thought so. What did they return?
They can return void.
Right.
We can have that in same formatting, so it would be uppercase B and uppercase L.
Oh yeah, true. Consistency matters, isn't it?
Yeah.
And then bind that. Well, it's the same arguments as the C style, the C bind.
It will be, yeah. So we can just implement those two functions. It'll be really simple.
Socket. So yeah, the TCP socket.
No, because we're going to bind. We're going to bind to. When we do TCP socket.bind, we're binding to that TCP socket. So if you just right-click the bind function in the header file, because right now you're in the a different source file. Yep. And we're going to do if bind passing HSocket.
Oh right, like that. Oh, fair
Yeah,
enough,
yeah.
fair enough. Okay. So H socket, that makes sense.
Yep. And the next parameter will be ip.getSocket address pointer. Or be IP address, because that's what you called it. Yeah, IP address. We can just simply cast that to a socket pointer. And we don't need to do the ampersand before socket address. We don't need to do that, because it's already a pointer. We can just get rid of that. So it would just be const socketed pointer, and we don't need to give it the ampersand after that because the socketed. Actually, let's see.
It complains though.
Oh, rather than using get socket address, use get socket address pointer.
Oh yeah, yeah.
Different, yeah.
We can remove that. So we have a whole new function just to not put the reference
Yeah.
operator in.
Yeah.
All right.
Because if you were to do address of IP address or get socket address, that would give you an address for a temporary variable.
Oh yeah, true. Yeah, it would be temporary.
Yeah.
And then
The last parameter is the size of the IP address dot get socket address.
RTOS.
No, it'd be IP address dot get socket address.
Bro, how do I hit RTOS?
I don't know.
And then yeah, so if then boom. If that's
And
true.
if that returns a socket error, we will throw an error saying failed to bind. And just for the sake of readability, we can put the parameters of the bind function on different lines.
Yeah, I'll do that in a sec.
Yeah.
Yeah.
Back in a minute, but I'm sure you can implement the listen function as well.
Yeah, I'll give it a go.
Yeah.
Backlog. Oh, what was it? What does backlog mean? Defines the maximum length of the queue of pending connections. Oh. Two. That reminds me. I actually set it as 1 in this one. Here. So I'm gonna set that to 2. Even though we're not gonna use it anymore, just set it up there. So 2. Ek, you're done. You're done. How was your meeting? It was long, yeah. Okay, good. We like long meetings. Listen to that equals socket error. Who's spamming my phone? Throw std runtime error. Failed to listen.
Failed to listen. And we don't need to pass any. So the flag of that should be 0.
All right, thank you, Cassandra. The flag, it's backlog.
Yeah, it's fine. I'll check the drops 1 sec. Okay. Maybe set that to be 10.
Ten users at once. That would be crazy.
Yeah, sounds good.
And I'll just put a reminder myself. Backlog is
What the key of these, I think, is.
Sorry?
The maximum length. It says the backlog argument defines the maximum length to which the queue of pending connections for the socket may grow.
Yeah, so like maximum number of clients.
Maximum number of clients that are joining.
Yeah.
And we just want, instead of checking if it equals socket underscore error, let's see. Oh yeah, that's absolutely fine. Yeah, no, don't worry.
I was
That's
gonna
okay.
say.
Yeah.
Okay, cool.
So we can now use that TCP socket class in our client and our server.
Yeah, so alright, so instead of doing all of this stuff, we can just use the custom thing we made.
Absolutely, yeah.
So let's see what was it. TCP socket. In server main. Where did we make TCP socket? I don't think we did. I don't think we actually implemented it.
Yeah, it wasn't finished yet.
Oh, so now it's fully finished. Yeah.
I'd say so, yeah.
Seems like it's got everything. So I can remove that to do.
Yep.
And it seems all good. Now, yeah. Okay.
We can practically delete all of it.
Yeah. Oh, we don't have
It's,
we don't have closed socket.
we don't need to worry about that. It's done in the destructor of the class.
Oh. Oh yeah. Oh yeah. Yeah, up here. Okay.
In the destructor, yeah.
That one. Yeah.
So that's what's meant by lifetime. So the TCP socket, and the lifetime of the TCP socket, when it's created, we create the socket, and when lifetime is over, if it's a valid socket, we close it. So we don't have to worry about this manual close socket sort of thing. It's done for us by lifetime.
Okay. But the last thing, WSA cleanup, we do need that there.
We've got the WSA class that does that for us as well.
Oh, shit, really? Oh yeah, we got that. The destructor does that.
Yeah. So the WSA is tied to the lifetime of that object that we create. So we'll just create a WSA object, and that will be tied. That will tie the lifetime of WSA to it.
But when does the destructor get called? Like, well, so when we return 0, when main finishes, that's when it destructs.
Many places. So if there is ever an error thrown that we not recover from, it will close it in automatically, so there's no sort of leaking of memory. This is why C++ is safer than C. Is that all the edge cases are covered by destructors.
All right.
So we can practically delete all of the code there, maybe except the old like receive and send, because we'll just convert that to our new code. But we can just use WSA or WSA object rather than calling that manually.
I'm gonna comment it out.
Sure.
So, also Board Game Maker says the destructors get called when the variable goes out of scope. But
Yeah.
But in the main function, there's only one scope. Like,
What about the cases where we throw an error?
Yeah, but if we don't throw an error, when we get to line 147, when we return 0, the program finishes, but it doesn't have time to X out of scope because the program finished. So when does the destructor get called?
Right before the function ends.
So like right before int main finishes, that's when the destructor gets called.
I think it'll be after it, but we don't need to worry about the specifics of that. All you need to know is it as a board game maker said, it will call the destructor when it goes out of scope.
It's a skill issue preventer. Okay.
Nice.
So
I'm getting fatigued of all these Zoomer terms. Skill issue. Oh.
I think, well, that's done then. I can delete that.
Yeah. So we
User
can just-
data, that's like for fun. WSA data, that is our thing. No, wait, we don't need this anymore.
No, we don't need that.
No,
Just make an instance of the WSA class,
we need
and
this.
that will
now.
sort itself out.
So,
We can just type in const WSA, and the reason we're making it constant so we don't assign it and then therefore create another do another WSA sort, when that doesn't make any sense. We already sorted it, if you know what I mean.
yeah.
Alright,
Well,
perfect.
Just do the same for this one.
Yeah, sure.
Okay. Oh. Okay. Oh, and then we got to do threading after. But client started. I'll just do here as well. Why not?
Yeah.
Okay. So we got the WSA, and I'll do client after. Okay. And then we need the WSA initialize WinSocket. That
From for us.
initializes it for us. Okay.
Yeah.
The iResult. We did the iResult.
It's already done for us. Everything's done for us in that class. It's so simple. It just calls WSA solved if there's a problem. It throws an error, and in the structure it will close WinSock. WSA.
Okay. Cool.
Now we can use our TCP class to accept user input or bind and accept user input. Well, use incoming connections rather.
Yep. Boom, boom. So first we're gonna create the socket now.
Yeah.
So,
It's the TCP socket class.
yeah, but doesn't it return something?
No, just literally do TCP socket.
Oh yeah, that's what I meant.
Yeah.
And then this is gonna be the server socket.
Yeah. And we'll
Oh,
initialize that with an IP address.
what is going on here?
You haven't included it.
Oh, little monkey I am. Let's do this. So, include. Oh, both of these ones. Oh wait, what?
In this, it would be prefixed with library /.
How does it work in? Oh, okay. Fair enough. And then, like, and there is a lot of copy and pasting going on here.
Sorry.
These two lines. If we could just put this in. If I could just include the TCP socket. Oh no, that wouldn't work. Wait,
It's all right. It's not a problem.
okay, it's fine. I'll just leave it like that. Then. It's getting a bit confusing. Okay, we include threads. Oh, we don't need it. We don't need threads for the client one, just the server, isn't it?
Yeah,
client
just the
only-
server.
Yeah, it only
the
cares
server.
about the server, the client. So.
Yeah,
All right, good. Server socket. All right, and then.
I think so. Anyway, we'll get to it when it comes. So first of all, we're going to create it using an IP address.
Why don't we use this one?
That is for a different purpose.
Right.
That's when we've already got a socket. We need to create it first. So you got to like it's a function. As the IP address is a function. So because we're constructing a new IP address. Yeah. And what is the parameter? So you're passing an IP at what?
There's many. It's
Yep.
gonna be this one.
No.
No? Oh,
It's gonna be the string one. So that'll be you'd pass in 127.0.0.1 and the port will be 6969.
I don't want to hard code that.
How come you're using a pound define? You could just do const string IP address equals 127. Blah blah blah.
I don't know why I did that.
Port will be an unsigned short. It won't be a string, it'll just be a number.
Oh yeah, forgot about that. And then yeah, this one wants the sock address.
It will be localhost and then default port. Remember, we made
Oh,
that
the
class to make
string.
it all easier. It's supposed to be as easy as possible.
I was looking at the wrong definition. So the string IP, local host, and then
Yeah.
port. Default
Yeah.
port.
Okay. And then we bind to it and listen to it. That'll be server socket.bind and server socket.listen.
And then it doesn't return anything, it's void, so server socket.listen. And then
Okay,
bind,
perfect. Then we can just do while true
and then accept
and then
one
receive
client.
the socket, receive the incoming connection. Do while true TCP socket incoming connection equals server socket.accept.
Incoming connection.
Yeah. Because we're going to accept a new connection.
Oh yeah. I'm a bit slow. Okay. And then
Right. It will just be equals socket equals server socket dot accept. Yep.
Yeah, it returns a TCP socket. Okay. Just gotta remember what I actually wrote in. And yeah, so they accept it, and then
We're going to receive some data from it or send it. It's up to you. Maybe for testing, we can just send over a hello string to the incoming connection. Yep.
let me figure this one out. So yeah, it would be this one first.
It will be the easiest one.
Bro, I suck. Okay, string data. It's gonna be whatever we want. And then the destination is incoming socket connection. Incoming connection.
Perfect. Yep.
Sick. Now let's try it out. Oh wait, the client. We have to make the client accept it as well. So,
Yeah.
Server's
you
done
just
for now.
do a similar thing.
Meow.
Hello? Bro just said meow.
It is me.
Right, yeah, so
So-
I wonder if we've got ephemeral ports in our IP address.
Yeah, client.
If you set the port to 0, then it'll be ephemeral, so it'll choose it for you.
Okay.
Mr. Question Mark.
Yeah,
What should I call you?
I'm Jamie.
Jamie, could you quickly read my last DM?
We're just getting it all up and running before we start moving it to threads.
Fair enough.
Yeah,
think we
one thing
should
at a time.
Already be doing this in a separate class, but your lesson, you go ahead. It's up to you.
Yeah, you need to learn how to do it this way, and then we can move on to threads.
Yeah, I just never. I personally don't work that way, but I know people do, so it's it's a preference thing.
So accept. No, it's receive. No, wait. It's bind.
We need to bind to it, I
It
think.
is bind, yeah.
Yeah, and then we just listen. Yeah. So well, true will receive.
Wait, we only listen once?
Yeah.
Oh yeah. Listen, that connects us to the server when you do that once.
Yeah.
And then
So we just. I remember our receive function, I think, returns a string.
yeah, the data, isn't it?
We just do client socket dot receive, and it should take in IP addresses. Let's have a look. Oh no, we need to make a socket for the server that we're not going to bind to. Okay, that's what we're going to receive from. Oh, actually. Oh, in fact, no, I think we're all good, actually. So, right. Alright, I know what to do. So, instead of setting the IP address, the port of the IP address to 0, make
Yeah.
it 6969, but we won't bind to it or listen to it in the client. So all we're doing is just making a socket to the server, and then receiving data from it.
What does accept do again?
Except we'll give you a socket to the incoming connection.
Oh yeah, okay, good. Perfect. So I was on the right
Well,
lines. Server
yeah, but listen.
Yeah?
We don't need to bind or do the listen function.
In the client.
Yeah, we need to do that. And we can just call that server socket. I think, yeah.
This is getting confusing though. Server connection and server socket.
think if we just do
Need a better name.
the server socket dot receive, and that will give us a string.
That will give us data.
Yeah, that will give us a message. And we can give it a maximum number of bytes to receive.
Oh, we can do whatever we want. 10,000.
Maybe not 10,000, that'd be a bit too much. Because remember, it's going to be allocating 10,000 bytes every time you call that function now.
Oh, that's a lot. That's a lot. Oh, so this is gonna be the maximum amount of bytes we can send per message.
How many bytes we can receive? We can send unlimited bytes to the server. But obviously, if it's more than the number of bytes the server's expecting, it may not work properly. So I don't know, maybe set it to 1,000 on both sides.
Yeah, we should have a
So you don't-
common max bytes.
Sure.
What does max byte mean though? Like this. 0x.
That's the biggest number you can represent in 1 byte. That's 255.
Oh yeah, because 15 times 15.
Yeah.
Yeah, 225. Okay, cool. Oh, this is some nice stuff as well. Okay. So I'm gonna make another constant. Max bytes. What's a good one? 1,000?
Yeah, 1,000 will do it. 1 kilobyte.
How many words do you think we can do that? 1,000 letters?
1,000 letters, be about
Yeah, 1,000 letters, okay. That should be enough.
200 words. No, not 200 words. I don't know.
Quite a few words there.
Yeah. A
And-
lot of yap.
But if we send more than 1,000 bytes, it just gets cut off, right? It doesn't break anything.
Yeah, I'll just say cut off.
Oh, that's fine then. That's fine.
Yeah.
And then let's just do...
Let's put a new line on the end of that as well.
Oh,
What's the issue?
no issues found.
So sort it again, and this time click on retry. So let's retry on the server. See what click on retry on that little message box there, yeah. And what does it say? Okay, this is where our exceptions come very handy. So what we can do is, if you go back to your client.cpp and your server.cpp, just before we make the bracket, type in try. So there should be int main void and then try at the end. Not there, no. Right after you say void and then the parenthesis. Yeah. And then at the end of the function. No, don't worry about that. Don't worry about that. Yeah, just like that. Yeah. And then at the end of the function, type in catch. Where the red squiggly line is, yeah. And we're going to be catching a const reference to a runtime error. Not there, other way, yeah, other way. And then we can just use C error to print that out, error out using the .bot function in the error. And we can do the same for the server. Perfect. That'll not tell us what's going wrong. So according to the server, it failed to bind.
The client is somehow getting to the while loop. So it didn't get any errors so far, the client.
Yeah.
Weird. Client started. Okay, nothing else there.
Let's just diagnose the server first. Go back to our server our server code and have a look what's going on. What do we say? Localhost for binding to the default port. 69696. 69696. Right, okay. Have a look at your bind function in your TCP socket. That's it here.
Maybe it's the C style casting.
Doubt it.
I'm just gonna check the parameters again. Socket, yeah.
Sure.
And then socket address, pointer, yeah. Name length. Maybe no. Or if I try this, no, that's not gonna.
Have we initialized it correctly? Let's have a look at the constructor for TCP socket that takes in an IP address.
The constructor.
Yeah. And the constructor we're calling only takes in an IP address. Okay, I see the reason why it's not working.
Yes.
We've already bound to it. You see there on line 39.
Ah, a bunch of silly billies. What the hell?
So let's not call the bind function in the server.
Yeah, simply just delete all of that.
No, keep it. Just in the main CPP of the server, just don't call bind. So it's already bound to it, that's why it's causing an error.
Alright. But if we have the same code twice, that's redundant. I should remove the bind function.
Yeah, go for it. Yeah.
I'll comment out at least. Just in case. And here I will comment this one out. That's it. Okay, good spot.
Okay.
Now the client got the error.
Okay, that's fine. So what you want to do is in your client code. Where's your client.cpp? Right, okay. We're going to make, instead of the server socket, we're going to call it client socket. Set your port to 0. And we want to accept an incoming connection from the server in the while loop. In fact, no. And line 24, TCP socket, server socket. And we'll set that to be equal to client socket.accept. Yep. I think that'll work. Okay, and rather than that, we're going to use server socket instead of client socket there, yeah. Invalid socket. Okay. I will take a look at my code right now.
Alright.
Okay. Um. Okay, so what we're going to do is we're going to keep the old member function for binding and not have it in the constructor.
All right.
Because what's happening is we're making the socket and it's binding to it. And we've already bound to it in the server code, so it's giving you an error.
That does make sense. Keep that one.
Yes, we'll keep that and then get rid of the one in the constructor. That's all good. That's fine. Okay. Now we have to bind to it manually in our server. So we have to bind to it, then listen to it. Yep. And in the client, we have to bind to our client socket. But don't bind to the server socket, just bind to the client socket. Before you accept a connection, bind to the client socket. Try that. Socket again. Problem receiving data. Okay.
Yeah,
Okay.
so go up to line 29 then.
Thinking. What if we set this? Go back to your client code and set it to be set the port to be 6969, and we won't accept a connection. So we're just making a socket to the server IP address and port, but we're not binding to it. We're just receiving data from it. So we can get rid of those two lines.
These two.
Yeah. And just instead of 0 for the port, we'll just use our default port there. Let's try that.
Did the
Wait 1
server even
second.
send any? Oh, it did.
I'll have a
Something
look
wrong
at
with the
code
send
now.
function then.
Yeah.
Oh, hello, Yuso.
Okay. I know the problem.
Yeah.
We need to send a message to the server, I think. Actually, let's see. So it's accepting an incoming connection. So we need to send some data to the server. So let's rename client socket to server socket.
It's expecting data first, isn't it?
Yeah.
Ah, that makes sense.
And we're going to make another socket at the top called client socket, and that's where we're going to set the port to 0. I meant like line 24. Yeah, there. Yeah. You just pass in localhost and put the port to 0, because then it will automatically create a port. So what we can then do is send a message to the client, send a message to the server before we receive anything. So in our while loop, we'll just do client socket.send some data to the server socket.
We only want to do it once though, not in the while loop.
You can give it a go, yeah. See what happens. You can just type in normal string, just type in hello, yeah. That'll work. Yeah, try that. Okay.
Yusuf says we don't need to bind the client socket. Did the client call connect after creating the socket?
Let's see. What's this? Did the client call connect? Ring socket.
Did the client call connect? We don't have a we don't have a connect.
No, we just have. So what happens is we create the socket within the constructor. We then send a message to the server socket. Then we're receiving a message from the server socket, and then print it out hopefully if it works. We haven't got a connect function. We can make one, that's fine.
This don't make sense. I'm checking if it's empty, and if it is, continue on to the next iteration. So it won't print out server said, but it's still printing it out.
It's alright. What we'll do is we'll make a function in our TCP socket called connect. And it will take in a const reference to a TCP socket. Be like void connect. It'll just take in a const reference to another TCP socket. Let the TCP socket be const. Yeah, there we are. And then we just call the connect function. That's the C connect function. That's lowercase. And the first parameter will be sock underscore stream. An uppercase sock underscore stream. And then the next parameter will be socket, as in that parameter we've given it there, socket lowercase dot IP address dot get socket address pointer, and then we're going to do the size of socket dot IP address, and we'll pass in the get socket address. And it's already pointed. We just sort of cast it to a. Let's see what it says in the docs. A socket.
Still having a go at me.
Let's see.
That one's there. That one's there.
That's all good. Oh, hang on, no, not that size of. After socket IP address, type in dot get socket address before the parenthesis, because you want to get the size of the socket address. Yeah, and we'll just return the size of that. Okay. And if connect returns -1, throw an exception saying failed to connect. Alright, okay. Now in our client code, we can just call the connect function to our server socket. So we just do client socket dot connect to server socket. Alright, let's have a try that.
Go to connect to server.
Failed. Hmm.
That's the connect function.
Okay, let's bind to the client socket. Before we connect.
I thought I need a server binded.
Hmm. It's very strange.
Linux, what on earth is that face? Again, you managed to pull an emoji from hell. So, that's how you look in real life? Crazy. I recommend watching the stream instead of studying. No, connect. Socket? Yeah. It says it wants a socket. So why are we putting sock stream?
Is that what it's saying? Because on the docs it was. All right, let's
Yeah.
have a look at that function.
It wants a socket.
Oh, right, okay. That'd be socket dot hate socket then, wouldn't it? But the Linux doc said it wants a file descriptor. Linux doc's confusing me. So yeah, it'd be socket dot hate socket. And what are the rest of the parameters of connect?
Sock address, name and name length. So that's all good.
Yeah, that's all good. Yeah, perfect.
I was wondering why we put sock stream. Okay, still cooked.
Okay, let's have a look at the client and the server.
Maybe the bind.
Let's try not. Yeah.
I think we need that. Nah.
All right. How about we have one incoming? So rather than putting the incoming connection in a while loop, we'll just put that on another line. So we only have one incoming connection just for now, so we can see what's going on. So on line 52, we'll move line 52 to line 48, so we only have one incoming connection. Yeah. All right, let's try that. But I'm looking at the server socket, and we're not sending anything useful. We're just sending in a blank string. So go to your server socket, server there, just like test.
Yeah, because it wasn't sending anything. Oh, now it is.
Perfect. It's a lot of tests we've got going on there.
That's really fast. It would be
That's good,
faster
isn't
with
it?
printf, wouldn't it?
It wouldn't.
Someone said it would be a few streams ago.
Very nice and fast to look about.
Oh shit, I've been streaming nearly 4 hours. That is insane.
Yeah, but it's working, isn't it? It's worth it.
Yeah.
Sending over a lot of streams. Right, okay. Cool.
I'm gonna get some water real quick.
Alright, over it.
Bro, what did I just read in the chat? Nah, what the hell? It would be. Bro, what is this? Yuso has a wife. Yeah, he has a wife. Oh my. Hello.
Hello.
I just did a pull up. I banged my head on the ceiling. It actually hurts.
Oh dear.
Can you do pull ups?
Yeah.
How many?
Too many. Too many.
That's gonna be cap. How
I
many?
can do a pull up so fast that it looks like I'm not doing it one at all. I just-
Usual says the port is already bound.
Works. I mean, look how simple that code is there, Gabe, compared to what it was before.
Yeah, that's insane. Oh,
So it just makes sense. Like as you look at it, it just doesn't. There's no nonsense. Like
Logic.
there's no RECB. There's no MBSTOWR, like long stupid C file C function names. It just makes sense. That's what it should make sense.
you know what this code reminds me of? It reminds me
What?
of exactly how the HTTP server in Python looked like. It was exactly just this stuff. Everything was abstracted from you, and you just had these simple functions like connect, send, bind, listen. That's all you had. You can make it really simply in Python.
That should be. Yeah. So is this going to be a HTTP server or a text chat room server?
Well, I called it HTTP server, but I think I'm just gonna leave it as a chat room server.
Yeah.
I should change the title of the stream otherwise it's clickbait. Yeah, it also says the port is already bound. Did you get any solution, Jamie?
We're only binding once. We're only binding to the server socket, and then we're connecting to the server socket, and then using class socket to send a message so the accept is fulfilled, and then we're receiving. What this program is just basically DDoSing your network, because if you open it, it just test everywhere.
That's fine.
Yeah.
I've got gigabyte bandwidth,
Oh yeah, nice.
I think.
I've got the what's it? Virgin Vivid 500 or something like that.
500 megabits per second.
Yeah, well, I've got a really old TP-Link dongle, and it's just so unreliable. Like it gives me like, I don't know, 20 megabytes. Should be getting 50 megabytes. Probably more than that, actually. Probably what 55. But the thing is, the router's only in the other room, and it's not getting good reception. It's
Alright.
literally in the next room to mine. It's still getting bad reception, but it's fine downstairs. Like downstairs, my phone gets like full 500 megabits. Proper weird.
This is my one. Hopefully I don't dox myself by accident.
That's pretty good.
There's 3 different numbers though. Let's download up. Oh shit. Oh,
What is it?
I don't know why I'm stressing out. I thought I was gonna dox myself. Every time I go on those sites, they always show my IP, my real IP.
There's not much you can do with an IP address, trust me.
Huh?
There's not much you can do with an IP address, so trust me.
DDoS me. And find out my
You-
general location.
It'd be within 100 miles of where you live. If I gave you mine, for some reason it says London, but I don't live anywhere near London.
Yeah, that's weird. Mine says my IP says I'm up north, but I'm nowhere near up north. That's a bit weird. All right, anyways. So what the hell's
As
going
I
on?
that according to speedtest.net, I live in Leeds, and I don't. I live far away from Leeds. And for some reason, I'm only getting 108 megabits a second when I'm paying for 500.
You gotta call them.
No, it's my dongle. Got an old dongle. Had it for years.
Your dongle's too short.
It's too slow, yeah.
Cassandra, we'll put it up out in objects when we actually fix it. Oh, but it is in objects. It's in the we got the TCP socket.
It's all done.
Yeah, it's all out in objects.
We can now start to do threading.
Wait, no, it's still broken.
No, it's not.
Yeah,
How is it? How is it broken? It was working. That's a good thing. So your server's always sending, but it's not ever blocking to wait for it to receive something. So your code is working perfectly fine. Your server's sending data, your client's receiving it and printing it out.
Oh, because it's constantly sending and it's constantly receiving. That makes
Yeah.
sense. So I was wasting time. Bro, I was wasting time for no reason. We could have progressed by now. I was procrastinating.
It's alright.
Okay, let's go on. So
Right.
we receive it and
So we want to start on the server, and we want a few threads that are constantly listening or accepting connections.
yeah. So to make a thread, we want to make a new thread everything. So thread.
I wouldn't do that. That'll make a lot of threads, and your system get clogged up and shut down.
Oh right.
Yeah.
So make the thread
So
outside
this,
the while loop.
yeah, and this thread will be called your accept thread. And you want to initialize it with a lambda function. Do you know what they are?
I know them in Python, but I don't know how to do it. The syntax in this language.
It will be square brackets, open parenthesis, and then normal brackets. Like like that. Then you can put a semicolon at the end of that. No, at the end of the function call. Yeah, perfect.
What on earth is this?
And they can just so the square brackets is things that you're going to capture. So I don't think we'll be using that here. The second parameter will be any parameters to the lambda function, and there aren't any. And the third one is the body of the function, which I haven't got anything in, so it's empty right now.
Oh, I understand.
Yeah.
Yeah, capture parameters and then code.
Yeah. I'll be back in just a second.
I'm gonna look on W3 schools for a sec.
Do you need an explanation of how lambda functions work?
I know how they work. I'm just looking for the syntax.
Okay.
But thank you. The brackets give access to variables outside of it. Oh. Lambda captures variable x by copy. Make an object that heartbeats. Oh yeah, that's a good idea. That's a good idea. Every 5 seconds, check if the client's still there. I don't think I've ever streamed for 4 hours in a row before.
Mm-hmm.
You just use it to capture outside variables.
Mm.
I'm not even sure what we're trying to do though with the thread.
So what we're going to do with the thread is continuously accept new connections. And the reason why that's going to be in its own thread is because the accept function will stall until it gets a new connection. So if you have it on a different thread, then it will always it will not upload the rest of the program.
You want to know a fun fact about Python? About their threads there.
Go ahead.
You can't really use threads in Python because it has a global lock interpreter.
Yeah.
That was one of the things that really annoyed me about Python. You can only use one thread the entire time.
It's interpreted, isn't it? So.
What do we do, really?
So let's have a look at the TCP socket header file, because what we're gonna do, I'm thinking right now. I'm using my brain to think about this. So. Right. So in the while loop, oh, are you busy? Gabe, that was the worst pull-up I've ever seen in my life. You're locking your shoulders. If you lock your shoulders, you won't get any gains.
I'm not trying to get gains. I'm trying to bang my head on the ceiling.
Yeah. Well, just so you know, if you ever lock your shoulders like that when you're going down on the pull-up, you will not be making gains.
Look, wait, lock the shoulders. What do you mean?
You're going all the way down and you're locking your shoulders at the end.
What,
you want to
like
basically be like,
protracting the scapula.
I don't know what that's called, but just you want to go barely as low as you can go, not as low as you can go, because then you'll lock your shoulders. Just go up and down, because you want to keep the tension on your back and your arms.
Oh,
if you
so
lock,
like that,
then
don't
you
do that.
when you go all the way up and then down, but not as far as you can go. Just continually pull yourself up. So when it gets like 10% down, or 10% to the end of your down, and then pull yourself back up.
So don't lock the arms out, is what you're saying.
Yeah,
Right,
because you want to keep yourself in tension
Right, how many should I do?
as many as you can.
No, give me a number.
As many as you can.
Give me a number.
20.
I'm not doing 20. I need to warm up before I do 20. I can do it, but not now. Give me one less than that.
Fair enough.
I'll do 15.
If you can. Yeah.
Right, I could have.
Was
done
that better
20.
than locking your shoulders?
Well, it's easier, but you don't get much gains if you don't look it. It's like cheating. It's a bit cheating, I'd say. My coach tells me to lock the shoulders, to lock the arms. Why are you watching the stream?
You will literally get no gains.
Huh?
Because you'll be constantly releasing the tension on your shoulders. You want to keep the tension.
Alright. So.
Right, so we're going to have a while loop inside that thread. That goes on forever.
Inside the thread.
Yeah.
Crazy, okay. So
Yeah, while
Yeah,
true.
true, and then
Just accepts a new connection. That's what we're gonna do.
I'm just gonna do this.
Sure.
And accept connection. So, oh, this one. Yeah, I'll just move this up here.
Sure. Yeah.
Why you haven't? Why? Oh, that's what the capture is for. We take the server socket as a capture.
Right. Yeah. And
No.
put an ampersand before the server socket.
That did not work.
That's it. Just put an ampersand before it. Not there, but in the capture.
Wait, this music's pissing me off.
Yeah.
So, yeah.
Yeah,
So-
just put an ampersand before it. Yeah. No, not in the thread, but in the capture list, the square brackets. So you can do ampersand then server socket. Yeah. There we are.
So I was right.
Yeah. Yeah.
Didn't add that bit.
Right. Cool. Hmm.
Debug diaries interrogating me. Just a teenager learning to code, failing a lot, and figuring out on the way. I think we should all subscribe to Debug Diary. Quick. Because, also a teenager learning to code. What can I say? But yeah.
Right.
Parameters.
One second, guys.
So that becomes a local variable. Oh no, that's a parameter. The lambda function is the parameter. So,
Right, okay. So that's all good. Now we need to have something called a mutex.
mutex.
A mutex, yeah.
Never heard of it in my life.
It's called, I think it stands for mutual exclusion. So only one thing can access it, but not both. Right?
So that's, so that's like in the lock thing that Xilius taught us earlier.
Yeah, exactly. Yeah. So at the top of the
That
the file, it will be std mutex, and that will be incoming mutex.
The top of the file.
Yeah. So before main.
Form.
Yeah.
New what? Mutex.
Mutex, yeah. And you need to include mutex.
Yeah. I mean, I'd expect mutex to be included in the thread library, but
It's mutex is mutually exclusive to threads in a funny way. Right, okay, so we've got the mutex. We'll recall that incoming mutex.
wait, I lost the code. Where am I?
It's just in line 27.
Oh, there it is. Okay. So
Yeah.
what's it in?
Incoming mutex.
Mutex.
And do you remember the reason why we're putting the stuff in a thread?
Yeah. So when we're waiting for one client to send, receive, or connect, we can also
Yeah.
do that same to the other clients.
Exactly, yeah. And incoming mutex is not going to be a function, it's to be a variable.
Oh.
Yeah. No need for parenthesis there, just not as normal. Yeah, that's fine. Okay, so in your while loop for your thread, you're gonna have a new scope after you get the incoming. So you click on, you make the open brackets.
In this while loop.
No, the thread while loop. So after you accept the incoming connection, you'll make
Yeah.
a new scope with your brackets, yeah. And you want to have a std : lock _ guard. You lock the lock guard that the other person was telling you. And you want to give it a template parameter, so that'll be a the chevron. So and then type in std mutex. Yeah, and then you want to call that lock, and you want to initialize that with the client's mutex. Or sorry, the incoming mutex. Right, so that means that it will lock it, and if someone else is in this function or using that mutex, it will block it so that you don't get two at the same time.
Yeah, I get that.
Yeah.
That makes sense.
And we're then gonna add in that incoming connection to our unordered map. And I recommend moving the unordered map outside of the main function.
Why?
I don't know. I don't know. Well, give it a go. Okay, yeah. Try and okay, yeah. Alright, cool. So we'll just use the incoming connection's IP address to initialize that there. So if you go back to the while loop in there,
Yeah.
after we do the lock. Oh, we also need to capture the unordered map in the thread. So have to in your capture, add another ampersand saying users. You know, on line 51, you got this. You're capturing the server socket.
Oh yeah, we're capturing users as well.
Yeah.
And after we lock
Right, okay.
it,
We then want
users at. We use an IP. Oh yeah. How do we get an IP then? It's just
it's in the incoming connection.
incoming connection dot.
Yeah. Get IP. I think we need to have a get IP address function in the TCP socket class. Yeah, just go ahead and make a function for getting that sort of thing in the class.
Yeah. That returns just a string.
Let it return the IP address. So return a const reference to the IP address. And in fact, the entire thing can be const expr. So it can be const expr, const IP address, get IP address. And remember to keep the name consistency. So it'll be capital G for get. Yeah. And this function will not modify the class, so it'll be const at the end. and you will simply return IP address in that function. No, it's fine as always before. It's like that, yeah. Perfect. So the incoming. Right, okay. So back to our server.
Yeah.
Go back to our server code. We'll then do after that dot get IP. So we're gonna look to where it says get IP address. We're gonna do another dot after that. Dot get IP.
How does that work?
To it. What do you mean? How does it work?
Oh, it returns the IP address type, the class, and then in the
And then we look into the IP address class, and then we get the IP from that.
and then get IP function. Yeah, that returns IP. There it is.
Yep.
But okay, yeah, I get it.
All right.
And then this.
What I would do actually,
Yes.
to go back to the while loop in that except thread. On line 58, type in. Not like that. So get rid of in fact just keep as was before. But at the beginning of line 58, type in auto, and then do ampersand user equals that. Yeah. Perfect. I'm just need a semicolon at the end of that. And then we can fill out the details of user. That'll be user dot and then fill it all out. Now the socket will need to. Okay, this might be a problem.
The debug diary can't understand a single thing here. Don't worry, neither can I.
The atomic weight of the substance and the speed of light, which is constant, and express their relation to energy in a simple equation.
All right, remove line 58 and line 59.
Remove it. Oh.
Yep.
Bomboclat.
And go to your user struct. Rather than there being a capital socket, it will be a TCP socket.
Yeah, that makes.
Okay. And go back to your while loop in the thread. I'm going to type in users dot and place. Yep. And then look through it. See what. Press up and down on your keyboard. I'll again. Okay. Instead of in place, do try underscore in place. Yep. Okay. And the key val will be incoming. The rest of you what we typed before, but I would recommend having that as a string. So that'll be const std string IP equals incoming connection dot get IP address dot get IP. No, not like that. Have it be a variable on a different line. Yep.
What is it?
The IP equals incoming connection dot get IP address dot get IP. Yeah. Okay. And then in the try in place, we'll add in the IP as a parameter. Okay. And the next parameter after IP will be type in user. As in the class, the structure name user. Capital U. Yeah. And then open bracket. As in like your brackets or parenthesis.
Oh, the curly brackets.
Yeah. Yeah, and then make a new line inside of those brackets.
A new what? New line?
Yeah, yeah. No, not like that. It's like a literal enter key press.
Oh.
Yeah, and again. And then type in dot socket equals std colon move, and then give incoming connection as a parameter. That's good enough for now. Yep. Yeah, it's all good. And then we've got a continuously running thread that accepts incoming connections. And now in our main while loop on line 67, we can go through all of our incoming connections. Well, sorry, all of our users and just send them a message. So on line 68, if press a new line and go like for const auto, and then it's ampersand. Yep. Square bracket. And that will be IP, comma, user. Okay. And then colon. In our users, yeah. And then we will send data to the user.socket. It'll be user.socket. That's their station's a socket. Yeah, that's all good. Let's try that. Perfect.
Perfection.
Now you can send. Now multiple threads can connect to it. So if you have like 5 different clients open, it will work. Give it a try. So if you
I'll just
go
do
there
it
and then
with the binaries.
yeah.
If I open the client first, it's gonna get
just won't
cooked,
work.
isn't it? Do
So
that.
that's server. That'll work. No, the client again. Look at that.
Oh.
And
six.
again. And again, and again, and again, it will work. See, each time, the number of bytes being sent, well, you can see that there's less and less tests each time. So that means your bandwidth, it's stretching your bandwidth there, and that's good. It's proven it's working.
Oh, that
So
is
before-
so cool. Yeah. It's
before it's
working with the
loads.
bandwidth. Damn, that is
Yeah.
sick. Yeah, because we put a 1000 bytes limit on the buffer.
Yeah. Now you're just DDoSing yourself.
That is so cool. The debug diary just called you my real life chat GPT.
I'm the real life ChatGPT. No.
I wonder if we can get to 1 test per line. Actually, this is really blowing up my PC. So 100% CPU usage. All the memory is used. The Ethernet is starting to look like some Chinese letters. And then the GPU, you're chilling. Now let's stop that before I get a blue screen. Oh, no.
Probably will actually get your blue screen. Easily. End all the tasks. Yeah, good. Alright, how cool is that? Look how simple that is as well.
Yeah, man. Well, the thread is not simple, but other stuff is.
Here it is. Of course it's simple, look at it.
Not yet, not yet.
Make a lock, then you get the IP address, and move the socket to the users list, and then we send data to it, and it works flawlessly.
Okay, cool. I'm gonna just leave that
Do you want me to try to explain more about threading?
there.
Instead of thread, use JThread.
I think it's alright for now. Thank you.
No, use JThread.
JThread.
Definitely use
What-
JThread.
What's that?
Rather than using thread, use JThread. So then thread.join will be called at the end of its lifetime. Which makes it safer as well.
Okay. Joins to what?
Say again.
Joins to what?
Joins to the main thread. So
Can it
that
do
thread that you
anyway?
create. Not necessarily.
A join basically means the thread says, I'm okay to shut down. You can kill me now.
Okay.
So that's what a join is. So normally you have to, at the end of the thread, call join yourself, but JThread calls it automatically.
Nice. So now just gotta get inputs for the clients. And then
Yeah.
and then the server receives it.
Something you should implement as well, probably at this stage, is catching messages of a certain type. Like, have the first number of bytes be allocated to telling the server or the client what type of message you're sending. Does that make sense?
Yeah, that's easy to do. Yeah, it's very easy.
I think this is a good stage, especially if we're doing it like this in a mail loop. We might as well get it over with.
All right, Gabe. So in
Just
your
what I
TCP
was-
socket.
Gabe, does what I said make sense?
Yeah.
Okay. Then,
1 second, Jamie. Got some people in the chat. Fight Scenes asks, how do you learn? Is it by building something? Yes, well, building something is always the best way to learn programming. And the debug diary. By the way, who are those guys you're talking to? I'm talking to Jamie and Cassandra. We're in the
Hello.
Discord server. You can come join it. The link is in the description. Anyone can join the chat if they wish. Anyone can join the call. I bet it would be more fun. A lot of fun with lots of people. As long as you don't distract
And-
us, it's fine.
And in the Discord, there will be ways to post regarding the topics that are available, like C++, if you have any questions. And either me, Jamie, or Gabe will probably try to answer it if we're available and having spare time. So this is completely voluntary. Any answer, any request, is voluntary. So don't expect too much of us. We're not gonna like sit here and write you a bunch of code. But if it needs something explained, just ask, and someone will hopefully be able to explain it to you. Okay, but do you want to try yourself implementing catching messages of different type?
Oh. I'm not sure what the best option is right now. What's the next step?
The next step is using templates. So if you go to your TCP socket, so go to the TCP socket class
Yeah.
in the header file.
Oh, header file.
Yeah. And another. So type in template.
Oh, templates.
Yeah.
Oh.
And then, yeah, you know it. Chevron. Type name. And call the data type. Yeah. And then that function will return int. So make a new line. Yeah, no, int. And that'll be called send. I'll uppercase like same consistency as before. And it will take a const reference to data type called data. Perfect. And it needs a TCP socket, a const reference for TCP socket for the destination. Destination. Destin. Yeah, there we go. And the thing about templates is you don't define it in the CPP file. So if you have a brace after that instead of this semicolon.
What? Remove the semicolon?
Yeah, just do a bracket like you would like implementing it there and then. Yeah. And in that function, we will simply return, send, and then pass in the address of data. And the next parameter will be size of data type.
Oh wait,
and
slow
you
down,
pass
slow
the
down, slow
destination.
down. Start
Right,
from the
you go.
beginning.
Right, so we return send. Yep. And the first parameter will be the address of data. A pointer to data. Yep. Next parameter will be size of data type. Next parameter is destination. And that's it, pretty much done.
So we're taking in destination as a third parameter, and then we're just returning it like that.
Yeah, we're just sending over. It's just a generic way of sending data.
But isn't this recursion?
No,
We're
because
calling
the
send and it's
parameters are
returning
different.
send.
The parameters are different. It's just calling a different version of send. It's polymorphic.
It's calling the sends on 39, I think. No, 38. Sorry.
Sorry?
On line 38 on TCP socket.
Yeah.
There's another send. No, in the H. On line 38 in this file.
Line 48.
38.
Oh,
Sorry.
38. Yeah.
This is the function that gets called. So even though they're named the same thing, because of their different arguments, we're gonna... The compiler's gonna understand which one we're using.
Yeah,
So therefore
polymorphism.
they're both named send. So now all you've done here is you made a template. So when you do the pointer brackets for a type, it will send the size of that type and the data itself to whatever sockets we want.
Okay.
So we can now, we don't have to do like an int one or a string one. We can just use this template instead to make a new send function.
That makes sense.
Anything I missed, Gimme?
That's all good, yeah.
One
No, the
question.
next one will be for receiving data, and you use the same sort of thing where you use a template.
So one question: if the data type is something like string, the size of the string is not necessarily going to be the number of characters in the string, right? It's because we're looking at the size of the data type and not that specific instance.
Yeah, I know. Yeah.
I believe in the case
Yeah.
of string, it will just be, because strings is basically just a pointer to the data. So it will be, just the size of string, the object string, which is very small.
Yeah, but we want to set, like, we actually need to know the number of bytes that is pointed to by the void pointer.
Here's what you'll do, Gabe. So on
Yeah.
line 49,
Yo.
type in template. and then chevron, nothing inside of it, and then int send, and then put a chevron after send, and let that be std string, and let it take in a const std string reference and also a TCP socket. That's also no, that's fine just as it was. So the parameter list, it will be a const std string reference, and after that a const TCP socket reference. And we need to give those parameters names, so it'll be const std string, or whatever.
What is it then? The data.
Yeah. And the socket will be called just destination. Yeah. And then we'll implement that just by using the same way as before with a curly bracket. I'd recommend just putting a new line as a template, and the promise list is also it's just easy to read.
By the way, did you already go over what templates actually are?
We don't need to just yet.
I did a bit of templates a few streams ago.
Okay, got it.
Right, okay, so with then on line 53, we will call send, and we'll pass in as the first parameter data.c_string. Next parameter, data.length, and destination. And we can then get rid of line 39. Yeah, and also remember to return the value of send on line 52. Right, and in TCP socket or CPP, we can get rid of the implementation of send to a string, because we've already covered that in the header file. Yeah. So if you go back to your header file now, I'll explain what we just did. So we've got a generic function called send, and takes as a template parameter data type, and just sends over the data using the function we defined earlier that takes in the void pointer. That's all good. And you can see that the size parameter is size of data type there. And that's good for structures. So if you want to make a structure, like so if you want to send over a play position of X, Y, and Z, that will work perfectly fine. But for things like a string, that will not work as you expect it to work.
Like the structure user data will work.
Not necessarily, but simple data structures like a few characters, a few floats, a few doubles, all that will work. The reason why I went with for a string is because the size of a string will be about 12 bytes. Even if we have 1,000 different bytes in it. So it will never send over all the data it contains. Because size of a string is 12 and not length. It's not the length of the string. That's what we're explicitly saying data length in line 52.
Yeah.
Another thing is that if we just called send as it was and then passed in the address of the string and the size of the string, we would be sending over data that is not good for a client to receive, such as the memory address of the string internally and its size and its capacity. We don't need to know about that. Like what use is it for the client to receive a pointer that is held on the server computer? It can't do anything with it. So what we've basically done there is specialize the send function. So it's generic, like it is there for every other type except for string.
All right.
So it'll work with float, it'll work for double, it'll work for any other simple data structure type. But for string, we want a special version of that where we're sending over the data of the string, not the raw memory of the string. We're sending over the characters of the string.
They're called primitive
And-
types, aren't they?
Perfect, yeah. Primitive types.
Yeah.
Or plain old data, what's called pod types.
Yeah, so I suppose the important thing is that the struct itself should not contain pointers. As long as it's sort of flat in memory, then it's fine.
Yeah.
If it has anything that's allocated anywhere else, then you're gonna have a problem because you'll have a memory address instead of the actual values.
All right.
Yeah.
Makes sense.
So we've got our generic function, send, and we're specializing send for string there. Got a special version of send just for strings.
Yeah, yeah, because it wouldn't work with the normal function.
Yeah, yeah.
You could do a similar thing with user data and tell it exactly how to transform the strings into C strings as well, and then send that data.
I guess in general, it would be good practice for any data types that you intend to send over the wire. You should have some kind of well-defined wire format that you use. And I would expect that mostly that will be different from the data structure that you would use in your actual program. So there's usually a distinction between the representation that you transmit versus what you have in your actual program.
And this is why JSON is the best format type for sending data over a network.
Protobufs
That's-
forever, man.
All right then. So
Do you want to make your own JSON compiler or parser?
me? Nah.
Well, That's all that ought to do, to be honest.
Doesn't seem too fun.
It is pretty good practice of a lot of tools that are useful.
If it's simple to do, I'll definitely give it a go.
I mean, it's basically just turning objects into strings and strings into objects.
So it's like the JSONify function in Python, right?
Yeah, exactly. Yeah.
I mean, it's kind of a nice self-contained exercise. The biggest challenge is trying to do it efficiently, because it's very hard to parallelize anything involving JSON.
Okay. So
It
now,
depends on how you do it, because if you're accessing files with a thread, you can't normally access the same file with two separate threads, even if they're from the same program, because Windows won't let it, because Windows wants one thing writing to it at all times, and only one thing to write to it. It's sort of like a mutex, but for files. Is how Windows does it.
yeah. All right, it's time to implement the client sending messages back. We can do that now.
I think should you not make receive templates as well, Jimmy?
Yeah. Yeah. Yeah, we can do that.
Probably not the debug diary. Oh, so just the same thing for receive. For what was it, the other one?
Yeah, we the same for receive.
Are you planning to tag the type that you're sending somehow so that the client can figure out how to interpret it?
Yeah,
Or
that's
do we
easy to do. Just have an enum. So what we can do, Gabe, is have a header file in our library called packet.
All right.
I'm going to define an enum class. As in literally enum then class, yeah. And that'll be called packet tag. Yep. I'm gonna open it up with a yep, perfect. And that can be something like client underscore connect. It's just like it's an enum. Yeah, client connect. Yeah. Client message. Or message. Maybe that'll be better. It's generic. Yeah. Alright, that's good enough, yeah. And then we can define some structs. So next will be packet underscore client connect as a struct.
What's this for?
This is so we're going to be sending over lots of data over the network, and we need a way of organizing what the packets mean. So what one packet will be for connecting. I'm not even sure if we need that, but see what happens. Another one will be for messages. So if a client sends a message, we'll tag that saying this is a message. And another one could be set nickname, perhaps, as a packet. I don't know.
Yeah.
Maybe that can be a command struct, a command packet. Maybe a message will work for that. I'm not sure because you can just interpret that.
A packet is basically just terminology for a set of data, and usually headed by information about the data itself. For example, what type of packet tag it is, or you know, extra information about it, allowing us to like always know that okay, the first bytes in this data will tell us exactly how to read the rest of the data.
Yeah.
Yeah.
I've got an idea. Let's on line 7 make a struct called packet. Or maybe just call it I packet for interface. I packet. Not like an iPhone, but capital I. Yeah.
It's very C# of you.
Yeah. And we'll have in there a virtual std string. I'll just call it, I don't know, 2-string. Yep. Takes in no parameters. And at the end it will say equals 0. Okay. And we need to include string, yeah.
Wait. I was just remembering actually. That I at the beginning. It reminded me of I enumerator. Do we have that in this one? In this language?
No.
I'm
We've got better things than we've got iterators.
Okay.
That's like vector.begin, vector.end, and all the rest.
I mean, you can have one if you want to. You can create it. But you don't need to.
Alright.
And 2-string will have a capital T for 2.
With capital T.
Yeah.
So what's virtual?
So what we'll do is we'll have each packet inherits from I packet, and that means they have to implement 2-string.
Okay, yeah.
And equals 0 will basically throw a compilation error if that function is not defined in the inherited class.
Okay. So to inherit, we do it like this.
No, you would just have a colon and then public iPacket. And you will see it may throw an error, it may complain that you have an implementing toString if you compile it now. Yeah. Maybe it's. Oh, it is actually. I don't know.
Doesn't show
Never
the
mind.
error.
That's
I-
fine.
I mean, it's probably because nothing actually included this
Yeah.
error. So, because it's part of exactly 0 compilation units, so there's no compilation error.
3 failed.
It's fine.
But yeah.
So, client connect. Maybe the client wants to connect with a nickname already. So we could have a string in there called nickname.
But it probably needs to be not a std string, but it probably needs to be a character buffer, like a character array. Because
No, because we're doing toString. We'll convert it anyway.
Right. Oh yeah. Sorry, I was still thinking that we would do this like with actual binary representation. But yeah, never mind. Continue.
All right. So yeah, we'll have nickname as a string member, and we'll then type in std string toString, give it no parameters, and at the end of it type in override as you would with const. In fact, we could probably say toString is a const function, so we can just before we say equals 0, we just put a const. Because there's no reason it should change the function. What's the issue there?
Because the const needs to be before, so it needs to be const virtual, I think.
What about equals 0 then const? Interesting. Oh, that's no worries. Const virtual.
So what do I do?
And at the end of,
This one?
we'll put override before the semicolon of toString. Yeah. And don't forget to put in a semicolon after a nickname and then put the toString on a new line. Yeah.
Yeah, I do have to correct myself. If you put the const at the start, it will refer to the return type. So it's just not possible to have const virtual functions.
That is so strange. I don't know why that is.
Shouldn't it be after string? It's definitely not where it is right now.
No, std string const will mean a const std string. All right. Yeah. Get rid of the const at the first bit then. See what happens. And then what we'll do is make it const override. Right. What's happening there then? That is so strange. Surely it works.
Yeah, but I think it's not matching it because it's trying to make it a const when the other one is not.
Surely const equals 0 should work. There's no reason not to.
I mean, you can just probably omit the equals 0.
I'll be back in a few minutes.
All right. Old Gamer says you might be able to make a method const if you put const after the method name. Yeah, we tried that, I think. Virtual method needs to be const too.
Yeah. So, but it was basically not allowing it to put it before the equals 0 or after it. So,
Shall I leave it like that?
well, that also didn't work. I think that still refers to the output of the function. So I mean, I think we can anyway continue without having the like the constant in the override. So if we take it out from line 15, we can. Why is it still complaining? Okay, yeah, now it's just complaining that we haven't defined it. Okay, so now you would have to probably have a CPP file where you implement this function. I mean, technically you can implement it here, but
Yeah.
so yeah, you would have to basically just return some kind of tag that identifies the type of packet plus the actual nickname, probably also the length of the name and then the name.
All right. Can you quickly explain what does override mean, please?
Okay, so when you are creating like a hierarchy, like an inheritance hierarchy of classes, you basically have the option of having functions that are defined like in the base class, in the parent class, and then you're just specifying that, oh, I'm specifically overriding the method from the parent. So that's what the keyword is doing.
Basically, in the parent, we're saying toString is virtual to say everything that is an I packet will have a toString function. We just don't know what that function is yet.
Yes. So the specifically yeah, continue.
And then in the packet client connect, we're saying, okay, we're gonna override the virtual function from being 0 to being whatever we tell it to be in the CPP file.
Yeah, and there's a little nuance here, because when you say a function is virtual, you basically say to the compiler that, hey, this function can be overridden. Because we also set it to 0, like we said, like equals 0, what that means is that we, like, basically that function does not exist. Like the pointer to that function is 0, null pointer. And it basically makes it impossible for you to instantiate iPacket. You need to create one of the subclasses instead. And they must override this thing. So there's no chance that somebody just creates an iPacket that is not one of the other types. Yeah.
Gabe, has anyone ever defined interfaces for you?
A refresher would be nice.
Interfaces are basically classes that start with the letter I. That sounds very simple, but ultimately that's all it is. And all it means when you see a function like that, or a class like that, it means that calling or implementing like that class can never be constructed by itself. Like just having something be an iPacket doesn't really make sense, because you need it to either be a packet client connect or a packet client message.
So the I classes, they're like the parents for the other classes.
Yes, but not really parent, but yes, like they have to have everything iPacket has.
So they inherit from iPacket.
Yes. Different languages does it differently. Sometimes, like, for example, C# does interface completely difference. You have to actually say interface. But
Yes,
it's
that's
basically just another word for class, even there.
I'm streaming.
Yes, so the other like the actual purpose for having interfaces is basically so that you can make some parts of your program only interact with other parts of your same program through this interface. That kind of restricts how much detail different parts can see. And this is usually done to make sure that you don't turn your code into a tangled mess of like incorrect dependencies.
Yeah, so but by doing this, we can basically say now we can create a iPacket like object and call toString to it. And while the iPacket itself doesn't understand what toString is, the fact that it will have been overridden will make it,
Yeah,
will
it'll make a bit
make
of
that function accessible.
right. It'll make a bit more sense a little bit later. I think actually, if you open the was it in TCP socket where you had the send function?
Before you leave this file, or go back to that file real quick, and just copy this std string and toString, and place it in the other iPacket class. The entire thing, both lines. Copy on that and paste it in the message at the bottom. Change nickname to message.
Sorry?
Change that to message.
This one?
Yes.
Okay. Right. So so basically the way that this will eventually get used is if you go a little bit down, you'll have so basically at some point we will, instead of just taking any data type, we're probably going to send only this iPacket object. And then instead of getting the reference like we do on line 46, where we call like send ampersand data, we will instead call like iPacket.toString, and then the length of that string. Does that make any sense?
A bit.
All right, guys. I'm gonna come back in 10 minutes. I'm gonna get myself some beers. I'm gonna go up and come back.
Alright then.
All right.
All right. See you soon.
Yeah.
Yeah.
You never implemented the receive templates, right?
Receive templates? No.
You probably could do it yourself, so you should probably do that just to
We'll give it a try.
get the syntax in your two fingers. Try to not even look at the templates above it, right above you. Don't get tempted. Don't cheat. And good luck.
Don't cheat. That was the whole way I was gonna do it. Oh.
You have until Jamie gets back.
I got 10 minutes. Wait, I want to read what BallGamer said. You can imagine polymorphism as automatically generating a switch statement or set of if-else statements behind the scene. So for example, you want to make an inventory system, but you have a lot of different items. All of these items you can use with a single press button. You don't want to type out a long if-else chain, where you check what item you are holding lots and lots of execute the right function associated with the item. Instead, you want this table automatically generated, so depending on the item you're holding, it executes different functions. Kind of like an set of if statements.
Yes, all of that is correct.
I will say that games in particular are notoriously performance demanding. So if you're making a game engine, you probably don't want to do it like this, because when you are basically anytime you do virtual functions, like virtual function calls or like this kind of indirection, you end up having to do extra lookups to figure out what is the actual address of the function that you're accessing. There's also some other like memory constraints, like you probably don't want to create a complicated class hierarchy for games. You probably want to do something like an entity component model. So yeah, I mean, it's technically true that yes, you can use it like this, but if you're doing it in a like a high performance game thing, it's gonna be tricky.
I need to take a break. So what I'm gonna do, I'm doing this for five half hours. Basically, I'm gonna do this template, or I'm gonna attempt it, and then after that, I'm gonna take a pause from the stream. And I might come back later. So
Well, I mean, you have been at this for how many hours now? 7 hours, 5 hours, sorry.
5 and
So,
a bit.
yeah.
And I did an
That
extra
is-
hour at school as well. But that was just like, what did I do? JavaScript. The web dev stuff. It was nothing hard. So receive. What does receive return? Why are you red? IP address is red. What?
It's because the code, the one line above, is invalid. So, like, if you go back to the, oh wait, this one. Oh, have you renamed something in TCP socket? Oh,
it's
yeah,
because of
it's
that.
Because
yes, exactly. Yes.
the private, I think, is being eaten by the error.
Yeah, because you need to finish the template statement.
Yeah.
Yeah.
Okay. For the receive though, where is that? So it returns a string. Okay. Oh, it's right here, bro. Is that it? Alright. So it only takes in max bytes. Receive only takes in one parameter. So why would I need to use a template?
Presumably because, yeah, because we kind of need to kind of multiplex in the other direction. So we were taking in, like, the send takes multiple different inputs and produces essentially one output, like one type of output. We kind of need to do the other way around. We need to change the type of data that we return based on that template, which is honestly seems a lot trickier than the sending part.
It definitely seems like it. So I'm just gonna see if this works. Wait, was it not max bytes?
Well, I mean, I think the max bytes is gonna be kind of determined by the data type, but I'm also not sure if that's even what we would like. I think what we would need to do, like broadly, and I'm sorry if I'm spoiling anything, but I think we would need to read, like basically from here call the untemplated read or receive, sorry. And read enough characters that we can correctly interpret it to the data type that we wanted, but we would have to like similar to what we're doing with the packet, like on the packet side, when we're doing like the toString, we would need to have like a static from string function that would take in a like an std string and return an iPacket of the correct type. Yeah, I'm not sure what is the exactly correct next step here. So
Okay, I think I'm done for now. I'm not gonna be able to finish this. I'm sorry everyone that was expecting more. I don't know.
just leave it to do.
Yeah, I'm just gonna leave that to do. Oh. Okay. That's gonna be it. Oh, what's this? Oh, the filters. I might as well save, yeah. But yeah, it does work. Multiple clients.
Yep.
Okay. Yeah, I don't know why I've got this going on here. Reset UI. I'll just fix it after this shit, anyways. Yeah.
Alright.
Thank you everyone for watching the stream. And thank you to all of the helpers that came. Like Yuso, Cassandra and Jamie. I appreciate you guys.
Alright.
Yeah,
Ciao.
that's it. See you later.